No, we're just going to do it live. Links in the description if you want to hang out with me. I got 2 cold beers, and I want to play with software because it's a blast. I think I've got a whole folder for Chris Bricker, actually. That's pretty cool. Yeah, everything looks great. Great. Man, I got my ass kicked today at work. So I am not ready for bed yet. I'm still getting over that one. The Mario, huh? What is the Mario? I remember this. I don't know what I was smoking. So I've got this counterpoise here, and then I have this like zigzag thing going on here. What did I even attempt? Yeah, 20 meters. That's what I thought. I was like, what did I even build this thing to do? All right, so let's zoom in. And it's Hollywood. Is it too late, Hollywood? Can you jump in? Good evening, Bradley. How's it going, buddy? There's my buddy Hollywood. Oh, what a treat. Oh, I'm so happy. This is going to be great. Oh, I'm so happy. Cheers, everybody. How many waves do we have here on this thing? Start at the end. 1, 2, 3, 4, 5, and some change. And a whole lot of common mode. Whole lot of common mode on this feed line. Good evening,
Testing,
Hollywood.
testing.
Loud and clear.
Magnificent.
Absolutely. Let's get this over. I don't know what I was doing. I guess I was playing, which is a great thing, right?
Absolutely. I mean, I don't know what I'm doing either.
Yeah, I just fake it till I make it. I'm counting. So I looked. I pulled this up. I don't know what Chris and I were talking about. So my friend Chris Bricker, he lives in an HOA, and we've been trying to think of all kinds of ways to get him on HF. But he's like, his HOA is like got an HOA on top of his HOA, so he can't even get away with, a piece of PVC hiding something on the backside of his house. So we've been trying to figure out what the hell we can do for Chris to get him on HF where he lives.
Sure.
Yeah. I saved this, and the last time I was looking at it, I was on 20 meters with it, and I was thinking, because I'm about to teach somebody new some Mamanagal, which I think is hilarious, right? Like me teaching somebody Mamanagal, right?
No, you got it.
I heard it. I heard you laugh at me. So I was counting waves. I
forgot to turn on the 7-second delay.
Oh, it's okay. Oh, you're looking at the right.
No, the laugh.
Bradley,
the laugh. I would have bleeped it.
Oh, the 7-second delay. You didn't catch it. Yeah.
The Eventide hasn't caught up yet. Right.
Oh no. We're gonna get a letter in the mail. It's gonna be about a week, but we'll get it right. Monday morning, there's gonna be a meeting about this.
That's right.
Bradley says the real radio voice has finally showed up.
Wow.
Yeah.
That would be Bradley.
That would be Bradley. Where is Bradley? I don't know what the hell this thing is, but I was trying to remember all the fundamental things that you taught me because
Good.
I need to start from the beginning with somebody who has never used software before, and I need to reiterate to everybody, I don't know what the hell I'm doing.
That's okay. It's all
But
about
mem-
playing. It's all about seeing, where does the signal go?
it, right, and then so I was watching something you and I did a couple months ago, and
Well, that
it
was your
dawned
first
on
mistake.
it was it dawned on me that um, there's somebody else I think waiting. Nope. It dawned on me that when you look at an antenna, right, from
Right.
your nano VNA or your analyzer, you're only getting the view, like you said, from that side of the feed line.
Right.
Yeah. And that's cool and everything, but
Right.
that's not what's really important.
Exactly. It's the wrong end
Yeah,
of the dog. Right.
it really is.
Hmm.
So this main gal basic. Let's go to something simple, like a dipole, and let's start. Where's the 180 dipole? 160 dipole. Let's get a 160 dipole and run that real quick. And where are
Hmm.
we at? 1.8. Let's run that. Go look at our current. I don't. Are we upside down? Yeah, we were upside down.
Yep.
Okay.
So that's just a whisker too long.
All right.
That's why you've
So
got that dip at the top.
so we're a whisker too long because it wants to. Right. It's trying to fold in on
Right.
another.
Right.
Right. So my Manigal has this feature. If I can find it, is it going to be in calculate and optimization? Do you use this at all?
What I don't like it. What I do is I
Yeah.
change the frequency. So if
Okay,
I
let's
know
change the
that that
frequency.
antenna is a little too long, drop the
And let's go
frequency down.
down.
Yeah, put it
Okay.
1.8 even. Yeah,
Let's see what it does. And look at the currents. Not much of a change. Let's
but
go
there's a
1.7.
little. Okay, so go the other way and it'll exaggerate. Yeah, good.
Is that it?
1.7.
Okay.
So we're out of band now, but that's okay. It's just proof of concept. Yep.
Ooh, it's beautiful. The current's a little lower though, right?
Yes, because the impedance is higher or lower. I'm not sure which. Probably, actually, it's going to be lower.
We
And
let's
yes,
run
it
it on
is. It
one
is
point.
lower,
It is lower.
and it's gone
So we're looking
capacitive.
at so we went from 42 ohms unfortunately down to 31 ohms,
Right.
and we're negative on the JX, which means
Right.
capacitive. Right.
Yes.
Sorry.
Correct. The
Capacitive.
bottom of the equator, which is the negative side, is capacitive. If you look at a Smith chart,
Right.
below that horizontal line, below the equator is capacitive, above it is inductive. So you've gone capacitive, and
So
you've lowered
so
the. That's true for all antennas that are too short.
yeah. What How to digest capacitive? Is this energy being stored and then re-released, or is this just
No,
energy being wasted?
have you heard the term Eli the Iceman?
Yes, from you.
Okay. Do you know? Okay, so if I quizzed you,
But it's
I'm not going to put
no,
you on
I
the
would
spot.
fail. I would
Okay.
fail.
Okay. So
Yeah, but let's do it. Let me get a text document. I mean, or maybe
okay.
a paint document.
Yeah.
Let's see. Um, you know what? I got this virus the other day called Windows 11 without my
Mm-hmm.
permission.
Mm-hmm. I feel your pain.
Is
I
it still called
understand.
MS Paint? It sure is.
Yeah.
Fortunately. Yeah. All right.
I
Let me
haven't played
draw.
with
I
MS
can
Paint
draw.
in ages,
Okay.
so you're the boss here. But if you were to draw a horizontal line like you would see on an oscilloscope, so you've got a horizontal line in the middle and then a vertical line on the left-hand side.
Horizontal line in the middle and a
Yeah.
vertical line on the left-hand side.
Yeah. Yeah, right. Perfect. And
Yeah.
then draw a sine wave as best as you can. Doesn't have to be perfect. Perfect. Great. That's close enough. Yeah. Okay. So let's say that this represents the current on a wire, on a resistor. So we've got we're probing it with an oscilloscope probe, but instead of a normal oscilloscope measures voltage. In this case, I'm going to say current, just to throw everybody off track. So It's looking at the current going into the resistor. Okay, it's doing some work that we're putting into this load, this resistive load. 50 ohm load. It's a dummy load. Okay?
Right.
And because it's pure resistance, it has no reactance. Reactance is either capacitive or
Or
inductive.
inductive.
Right. So there's no reactance, it's just resistance. What that means then is that the voltage and the current overlap. They show as one line here on our graph.
So
If I drew,
that's when we have a zero reactance antenna, like the
correct,
perfect antenna, right?
correct.
It would just follow the current, right?
The current
Hold
and the
on, I'm saying that
voltage,
wrong. The current and the
current and voltage
voltage
are both in phase. They
in
overlap
phase,
each other, and you cannot distinguish between the two of them.
right? And that is when you know for sure on at least on this side of the feed
Doesn't mean
line
you
that
have a good match, by the way. That's something else. All it
yeah,
means is
because
that it's purely resistive and has no reactance.
and it's taken everything you're throwing at it.
No, no, no.
No,
Don't confuse it. It's just keep it simple for right now. It's all we're talking about is reactance.
okay,
Okay. If it has no reactance, then the voltage and the current overlap each other, and it is viewed. If you take the red away,
mm-hmm.
okay, that's what it looks like. It's they are superimposed one on top of the other, and you cannot distinguish between the voltage and the current. They completely overlap each other, and it shows as one line. That's when you have no reactance, only resistance. Okay,
Okay, so we
take my
kind.
word for it, and then we'll go to step two, and I think it'll become clear. Just accept what I'm saying for right now, and then
I'm gonna stay my question. Yes.
okay, okay. Draw another sine wave, same
Mm-hmm.
height, same frequency, so one complete cycle, but in this time start it, yeah, right there. That's good. Mm-hmm. You're a better drawer than I am. Perfect.
I did good on that second one.
You did good. Okay. So let's now say, can you write up, put a label up there
Yeah,
and draw
I
it,
think so.
with the letters, yeah, and type out Eli, the Iceman, so that those following along at home here's what I'd like you to do. Take
Yes.
take the word the and make it small
Ah.
case.
Uh-oh.
So
Control
capital ELI and then small THE,
ELITHE.
and then
ICE.
ICE caps, and then MAN is small case.
Oh, M's not part of it. Got it.
Right. Right. Okay. That's the way to look at it. So what this is saying is Eli, L in the middle, is an inductor. And what it says is that the voltage comes before the current.
E is voltage. I remember that.
Yes. Yes. I is current.
Voltage.
I is amps. It's
Yeah.
current. Okay.
Yep.
So in an inductor, when the inductor, it's voltage first and then current. That's the Eli part.
Voltage goes into the inductor and then current comes
It
later.
gets delayed. The current gets delayed. The current comes out after the voltage.
Chris
So
says.
so
So
Chris
is it
the voltage leads and the current lags in an inductor.
Roger?
Okay? And if it's a and if you're taking notes at home, if it's a purely inductive load, is just inductive, no capacitance, the difference between the two, the voltage and the current, is 90 degrees. That's in a pure, perfect world. It's not. It can never go more than 90. It
Now
can go
why?
less, but it can never go more. Okay, so that's Eli. So
Okay.
now we look at ice.
All right.
So here it's the exact opposite. C is a capacitor, right? And here it's the current first and then the voltage. It's the exact opposite of an inductor.
Inductor, capacitor, voltage.
Mm-hmm. Right.
Okay.
So that's why, and I think this actually came from the military. Eli the Iceman. It's in
That
all of the ham radio
sounds
tests that.
military.
Yeah.
Yeah.
It's like the resistor code, right?
Right.
So it's so that's a good way. That's a really good way to get it in your head. Eli the Iceman. So an easy way to picture this, or to 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 deal with reactance, instead of getting all messed up with which one is ahead of this, and we have to measure with a scope and measure the current and the voltage, think of it as positive numbers and negative numbers.
It's so easy when you think of it that way, right?
Yeah. If I
You
have
either are or you're going to
yeah,
be in, yeah.
and the goal is to get to zero. So if I have a plus 10 and a minus 10 and I add them together, they cancel each other out and I end up with zero, right? If I have a plus 10 and a minus 5 and I add them together, the answer is plus 5. Plus 10
J- J-O's,
and
right?
just think of simple numbers for right
Okay.
now.
Right.
Really simple. Not antennas, not Eli the Iceman, nothing. Just numbers.
Okay.
I got
Total. I got it.
a plus 10, and I add it to a minus 5. I
We're
end up with a
still inductive.
yeah, but you're taking it a step further. Forget about
Sorry.
You're right. You're correct. You're
Sorry, I'm
correct.
trying. I'm
Just
trying.
but just do the simple stuff. It's just simple
Okay.
math. I got a plus 10 and I add it to a minus 5. I at the end of the day, at the end of the equation, the answer is plus 5.
Correct.
Right? That's all
Yes.
that is. That's all this is. That's all this is. The goal to get rid of the reactance, zero reactance, is zero at the end of the equation. So if I got a plus 10 and I want to get to zero, I have to add a minus 10. And those two then will cancel each other out. And I'm left with just the resistance. There's no longer any inductance.
Right.
Any reactance, I should say.
Because now you have a true LC circuit working for you
Yeah,
properly.
that's what your antenna tuner is doing.
I love antenna.
The
I just bought
antenna's
one
too
today,
long.
Hollywood.
What's that?
I just bought an antique MFJ manual tuner today for $60.
Excellent.
Oh, I'm so excited!
Very cool.
It's got a balun on board. It's got terminals for wire connections. It's got
Yep.
amphenol connectors as God intended.
Right. Cool.
I stole that thing for $60. Anyway, sorry.
Excellent. So this is all about the phase between the current and the voltage. That's all of that this is. If the antenna is too long, it's going to be inductive. It's going to be the Eli. Okay.
If it's inductive, it's going to be the Eli. That's important. That's what I
Right.
needed
That's
to know.
that's the Eli
Let me
part of
type
it.
that out.
Yeah.
If it's inductive,
That's too
what did we
long.
just say?
Too long. Right.
Okay.
And so the opposite is also true. Right.
I'm gonna act like I know how to spell right now. Capacitive's too short.
Mm-hmm.
Short. Wort. There we go.
Yep. And that's what you're doing when you're starting out and you're making a dipole and you're feeding it with coax. Okay. Again, real simple. And you start trimming the antenna to get the lowest SWR. What you're doing is you're trading the inductive and the capacitance so that they cancel each other out. And then it becomes a closer match to the 50 ohm coax. You're getting rid of the reactance. If it's too long, it's going to be inductive. And the voltage comes then before the current, and it creates a reactance that doesn't want to mate with the coax. Okay.
Right. It's got to go somewhere, so it's going to go.
You're trying to overlap. If you look at the two sine waves on the screen, the goal at the end of the day is to get those two to overlap each other. That gets rid of the reactance.
And the phase shift, right?
It's the phase shift between the current and the voltage.
Okay, so that's encompassing the whole thing that we're talking about. Got it.
Yep.
Okay.
Mm-hmm.
I've had some people poke fun at me about my 75 ohm coax feeders, saying that I'm out of phase, and I was thinking about that. I was like, am I?
If you're running more than one antenna, you can
I'm
be,
like,
but
I'm like, maybe as far as the window, right? Maybe as far as the feed line is concerned, but as soon as I pop out of the feed line, all bets are off.
in order to make the statement that it's out of phase, you have to have a control. You have to have something to compare it to.
Okay, so all that's
So
out
if
the
you
window
have
then.
two antennas,
Yep.
and one antenna, the phase angle is 0, that's your known. That's your standard that you're comparing antenna number 2 against.
That's our control.
Right. Then you can say antenna 2 is, 30 degrees advanced or 50 degrees behind antenna number 1 or 180 degrees out, which would be a complete reversal of phase. But you need that known in order. Otherwise, it's meaningless. If you only have one antenna, it can't be out of phase because you have nothing to compare it to.
That's what I thought, because I don't have a reference. I'm like, how can you call me out of phase?
Right.
I don't.
Hey, I've been out of phase all my life. I mean,
That's right. One of these things is not like the other, but if you don't have the other, then who's to call me out of phase, right?
Exactly. Right. So Eli the Iceman, if your antenna is too short, it has capacitive reactance. We have two choices. We can either lengthen it, so we're adding some inductive reactance to it, which will cancel out the capacitive reactance, or we could add a loading coil, which does the same thing. And we can also flip it. Let's say the antenna is a little too long. We're Salty Walt, we're out on the beach, and the antenna, we're using it for 10 meters, but it's a little bit too long. It's a foot too long, and I can't collapse it any more than it already is. I could add a capacitor in series, same as I do with an inductor, and the capacitor will undo that extra length. Okay? It's the same thing. If it's too long, you add capacitance. If it's too short, you add inductance, and it cancels out so that you get rid of all of the reactance. That's the goal.
Get rid of the reactance. That is the goal. I mean, when you have reactance on there, you know that you've got an issue.
Mm-hmm.
Oh, that's better. There we go. Hey, sorry about that. Okay.
Boy, I needed some Dramamine for that show. That was I was getting seasick.
I am so sorry. Hollywood, meet my friend Chris.
Hi, Chris.
Hi. I enjoy listening to your explanations of stuff.
Thank you.
I'm actually a computer engineer.
Oh, cool.
I design circuit boards, and And so a lot of this stuff, I've done the math on some of this stuff, and it can get a little.
Oh boy, Paul's here now. Oh boy, I better behave.
What did I miss?
You haven't missed anything. We were waiting on you.
About PC boards for computers that he's designed.
Yeah.
Oh, I have zero knowledge of any of that shit. So continue.
So I designed some pretty crazy boards.
He does
Right.
impedance matching down to the circuit board level on the Daily Hollywood.
Mm-hmm.
Oh yeah,
and that does become very important because the bits are going by so fast they actually do radiate. If you even a calculator, if you put a calculator next to an AM radio and you push the buttons, you will hear it.
Yep.
So getting those bits to land at the chip all at the same time, bingo, you got it.
Oh yeah. The board that I was working on has 150 differential pairs, which is it's a lot.
And there he goes.
It's a lot.
Yeah. So it's a different situation there because you've got a bunch of inputs. So it's like you're parallel feeding this chip, right? And you've got to get everything. So all the clock signals line up.
Well, there's a little bit of slop in most chips, and I still try to get things dead on every time.
Right.
Just because it's a good practice, and I've got the room.
Yeah. So what you're doing is, I would label it as parallel, and what this is in series.
Yes.
Okay. So it's one load, one antenna, and we're feeding it down one wire.
Now, I still do some analog stuff as well, and you do have to worry about this type of thing going on here. But we don't really get into the math of it. I've done the math.
That's okay, because I don't either. I don't like math.
Did it
Do you
in
have
school.
a fix-it button in your software usually?
No.
No, I usually just call the SI guys or the PI guys. And,
Explain to everybody
I've got an issue.
Explain to everybody who the SI and the PI guys are.
So SI is signal integrity and PI is power integrity. And you will converse with these individuals a lot, just to verify things, to simulate things for you, and they're highly just very important to have. Very important.
Yeah.
And I'll design an entire board and put everything down, and they do some pretty crazy stuff.
Right.
I do. So
yeah, the copper traces on the board actually become transmission lines.
Yes. I do a lot of high speed. I'm getting into like 10 gigabit.
That's crazy.
And so
you're playing with the speed of light at this point.
Pretty much. And so like traces have to be like done in a certain way. You have to start curving them. You have to start zigzagging them.
Right.
You have to start worrying about the weave of the PCB.
Yep. You get multi-layers, and you've got crosstalk, and you've got thermal, and there's all kinds of stuff going on. And unless you are in it from an engineering side, people don't get what all of the moving parts. It's tough. Yeah.
It's okay. Okay.
But it's fun.
I love building computers, actually building them. Yes. It is absolutely fascinating.
It's very much related in that respect.
Oh, it absolutely is.
Yeah.
Absolutely is. Yeah. And so when I went and took my general, which is when it started to get kind of more into the math stuff, like I already had an understanding of a lot of what radio is.
Mhm.
I do. So it was fairly easy for me, but it's not easy for everybody.
Right.
So
I'll give another parallel to this. I watch a lot of mechanic rebuilds and whatnot, for cars, and
Well, that's why
all
we
of
get
the
along, Hollywood.
absolutely, and all of the new
Yeah.
cars have high speed network and low speed network and multiple
Reference
routers built in.
lines
It's a
and
computer on four wheels.
resistance,
Yes, it is.
dependent
Yes,
So
immobilizers that keep
so
people locked out of their cars.
the high speed can has a I want to say is it 100 ohms, Ziggy?
I haven't gotten
I
into
mean,
There's a
It
load
varies
resistor.
by
It's
it varies by
Okay.
manufacturer, but yeah, around 100 ohms. I'll
But
put money
there
on that.
it's twisted pair usually.
No,
And
it is 100 ohms. You're right. It's 100 ohms
Yeah.
on the twisted pair side.
yeah. So I see frequently where someone will put a scan computer display on it, and they'll realize, okay, this can is operative, but this one here is not, and they'll stick it with an ohm meter, and oh yeah, sure, we're down to 25 ohms. So you've got a standing wave now on that line, and that's why that part of the car can't talk to the head.
Yep.
So
Yep.
it's simple. It's the same as what we're looking at in front of us here.
But
is my
CAN bus
point.
also has
Right.
a lot of flop though too. A lot of
Right.
flop.
Oh yeah.
But those wires can still get out of whack enough that like things aren't talking to each other.
Right. You
But
get
it's
salt
still
corrosion,
a
you get a
serial
rat starting
connection.
chewing on the wire, whatever. Right.
It's still
yeah.
a serial connection, which blows my mind, which means every single device has to wait its turn
Mhm.
or wait for an opportunity.
Yes.
Mhm.
Yes.
Mhm.
It's what is it? It's the UDP of
That's why you also have to have a good timing
Mhm.
on that as well. And,
Right.
Clocks are very, very, very important in circuits. And,
Right.
Yeah.
Right. So on AM and single sideband ham radio stuff, we're looking at this, and if you have an SWR, you're going to see it on your meter. You're not going to get the most power transfer into the antenna, but it isn't going to really affect how it sounds. But
Yeah.
it sure does affect if it's data
yes.
on the computer, right? And
Yes.
it will affect, if you remember when we had analog television, you will get a ghost. That's also caused by SWR in the transmission line.
Mhm.
From the transmitter to the 1,000 feet up, you've got a problem on one of the bullets and where the coax joins together. Yeah, you'll see a ghost. But on radio, on audio, no, you're not going to hear it.
I absolutely love this layout for you, Hollywood, because
Yeah.
you fill up the duck up at the top corner because I don't pay for this. And I get to have my friends over here off to the side. I get to have you in the sky. This is a wonderful layout. We should do this all
I
the
still
time.
have my head in the clouds. Is that what you're saying?
Oh.
There's nothing wrong
I
with
wish I
having
could
your
be
head
as
in the
high as
clouds.
you, Hollywood.
I regularly
Grouch
have my head
says-
in the cloud.
There you go.
Oh,
Paul.
yeah.
Literally.
Yeah.
Literally.
Paul, for everybody that's watching, Paul likes to jump out of moving vehicles above Earth.
Right.
Yes.
Yeah, not cars. I like to jump out of airplane.
I said moving vehicles, homie.
At least not yet. That'd be base jumping, right? If you're like jumping out of a car,
vehicle,
off a cliff
vessel,
or
whatever.
something. It's a vehicle.
And the plane doesn't have to be on fire for him to do it.
Nope. That's the only way I'm
even,
jumping out.
even better if it's not on fire.
Right.
Nope. Like, I'm going to still try to ride that thing down
Yeah.
before I jump out of that plane.
Yeah.
No way.
All right,
So-
Hollywood, are you go ahead.
So back to the antenna. Once we get rid of the reactance, see, this is where a lot of people get messed up, and they go, well, if I get rid of the reactance, now I have, and I'm using air quotes, a resonant antenna. See, this is Hollywood going, I only use resonant antennas, All
Air
right.
quotes,
But-
everybody.
But
I prefer resonant antennas.
yeah, but it doesn't mean that I'm going to have a good match. I can have a 500 ohm resistance on the antenna, even though it's non-reactive. And
That's crazy.
500 ohm resistor,
so hard to digest that.
Because they're two different things. They're two completely different things. One is simple Ohm's law. E equals IR. Okay?
I think everybody should get a tattoo of that.
Absolutely.
I'll do it if you do it.
Circle.
So
I get the circle though.
Let me bust out the tattoo gun.
So E equals IR is the first half of Ohm's law, and the second half is pi. P equals IE. And if you write those two down, you can mix and match, and you can come up with any combination that you want. If you want to solve for how much power is going into the stick, I got the stick out in the field, the AM broadcast tower.
All the math for any radio.
It's simple.
It still gets broken down into Ohm's law.
Of course, right.
It's crazy.
Yeah.
It might be this long equation, but like once you break that thing down, it becomes Ohm's law.
Yep.
I just did something really important. I don't know if anybody caught it.
I missed it.
Go ahead. Easter?
No, I changed.
That looks like a really good jelly bean.
No, I changed the height of this 160 meter dipole from 20 meters.
Yes.
Which,
whoa,
isn't this lovely? From 20 meters. Look, so we've got a 20 meter off the ground, 160 meter dipole. Look where all the concentrated RF is, guys.
Right. So why is that happening? Here's the thing. Yeah. Why is that happening?
Yeah, guys, why is that happening?
Because it's good to see it, and it's important to know, it's doing it, and if I raise it up, it'll go away. But why?
In this configuration, it would be it'd be broadside to the antenna.
But it's shooting straight up.
But it's shooting straight up is the interesting. How high is this?
20 meters off the ground.
20 meters off the ground. What are you tuning this to?
Yeah. 160 meters.
160 meters. So that's still because you're still close, like you're still within that 160 meter range of.
So you hit a key topic, and my Hollywood's coming out because the broadside of the antenna is going to be encapsulating everything around it, and since it's so low to the ground, right, it's going to be reactive to the ground. Yeah,
and
so it's going to what they call see the ground, right, and it's going to run away from it.
Yes. Well,
it doesn't want anything to do with it. Well, this is the radiation pattern. I'm sorry. It'll sink in. The ground will be a sink. Yeah.
This is so. If I'm not mistaken, this is more like one section of an entire sphere that you're getting because of how close you are to the Earth.
Bingo. You got it, Chris. Exactly correct. If I put that same antenna a mile up in space, it'll be a circle. It'll be a circle.
Free space. Where is?
But once I put it next to the ground, it reflects off of the ground.
Ooh, look at that!
And the reflection, the reflection that goes from the wire down to the ground, then has to bounce off of the ground.
There it is.
When it bounces off of the ground and reaches the same height as the wire, it is out of phase with the initial wave coming off of that wire. And the difference in the phase causes the pattern to change. That's it in a nutshell. So when you raise the wire, you are changing the phase difference between the reflected wave and the initial wave. They will either support each other, or they will destroy each other, depending on how bad the phase is and how strong it is.
There's phase. I can't say the word.
So here, there's no phase. because it's up in free space. It has nothing to bounce off of.
So this is what I would really like to talk to Paul and Carlos about. I'd like to like maybe do like whisper or something, coming like a really fast whisper burst coming down, so you'd get a lot of entropy as you're coming down, and be able to like test an antenna as it's coming down through the atmosphere would be amazing data.
I agree.
Amazing data.
I agree. And
so I want to take this off screen because this is absolutely unrealistic for anybody.
Right.
Yeah.
Right.
Yeah.
Unless you're
not
jumping out of a plane.
This is not
But
hand
then
radio. No, we are not going out with, what is this, like 300 feet of wire? No, it's not happening.
Well,
it could be done.
It could be done. You'd have to have a weight like big enough, right?
So what's a realistic 120 meter dipole, Hollywood? About 40 feet up or 50 feet up?
More
on average.
More. Quarter
no,
wave.
No,
quarter wave.
No,
half wave.
I'm talking about like actual, like you go to your buddy's house. Oh, I just I got my 160 up, and it's up in the trees, and it
depends on how much money you have.
40 or 50. I mean.
I mean, if you're a contester,
you're making this hard,
and you got a 400-foot tower.
Jesus.
I don't think we have contesters really. On
DX engineering.
I know that we do. I know that we do.
No,
I shouldn't say
Hollywood's just being the traditional ham,
devil's advocate,
and saying it depends.
It depends. That's right, Paul. You got it. Yeah.
So,
if it's me, my 160
Yeah.
meter ladder line fed, it's actually 600 ohm fed. It's too short. It's 150 feet end to end. It will load on 160. It's only 30 feet above the ground, and I've got salt water all around me. The salt water, the water table is 3 feet down. If I dig a hole in my backyard and I put my arm in it right up to the elbow, my fingers are in the wet. That's it.
All right, so we're going 30 feet, so 10 meters, right?
Yeah, my antenna, right, is 10 meters above ground.
I usually put mine 12 meters.
That's your
Robocop. That's way too low.
Yeah.
But I don't have an alternative. I don't have any trees.
Yeah.
Trees.
And that's okay. I mean there's still some action going on here. I mean, it's not that it's not radiating. It's just
it radiates. It goes straight up.
It goes straight up.
Yeah. It's an NBIS.
Now here's the kicker. How often are you on 160, Hollywood?
I listen on all bands. I talk very infrequently.
Right. Me too. I love
listening.
Building, designing, analyzing antennas. I talk on them almost never.
Most of what I hear isn't worth my responding to. Right. I hate to be rude, but that's it.
I mean, it's the facts.
I can't tell you how many times I've heard.
How do I sound? How do I sound? Let me equalize.
Talk into the right end of the microphone for starters.
How's my compression?
Yeah.
Yep.
How's my mic going?
So, I mean, it is what it is. So, and then there's FT8. That's always fun.
I love
it. That's a whole nother
I love all digital.
No, we're not talking.
I just triggered a bunch of people. They're watching cat videos now.
GS8. I love.
We're not doing it.
I want to get into all the digital.
No digital. Nope. Because that's a whole magic thing all by itself.
So now what did you do?
I have taken. So what I did is I took that 160 meter dipole and I put it to Hollywood's about average height above ground at 10 meters, 30 feet.
Okay.
And also I'm pumping 20 meters into it.
So I would like
Which isn't bad looking, to be honest with you.
Right.
That's a lot of. Hold on. Let's go to. I can hear it now. Let's look at the far field plot before we do anything. Oh, look at this. This is abysmal.
So I would like to simulate all of my antennas.
Before you even get out of the antenna, you're -7 dB. at the best.
Jesus.
Yeah, but that angle that you're looking at, I don't think is correct. If
No.
you go back to the color,
Okay.
right, and then you snap a chalk line on that, because this has happened to me a number of times. I've looked at Manigal, and it's deceiving the way it's showing. Now,
Yeah.
on the bottom here, on the bottom left, I can't see it on the screen, but there is a button you can press. It's hidden.
Slices?
Yeah. We don't see it in StreamYard, but it's there.
Okay. Oh,
And then you
I've got
can
it logo.
rotate that. It's still cut off on the left-hand side, but that's okay. We don't, as long as you can see it, we don't. Yeah, there you go. Right. Okay. And then you can change the other so that you get the dot right on the purple.
Right on the purple. Got it.
Mm-hmm. And now you read your gain. Your gain is 7.8 dBi at that
not
spot.
So
Okay,
what is
that's
this software
radically
called again? Mamamic? What?
Yeah, it's
Manigal.
MMANA-GAL.
MMA.
Oh, I'm sorry, Ryan.
MMAM.
MMANA
ANA.
dash GAL.
Okay. Oh, come on.
Anyway,
I'm trying to
find it.
install this on my computer here.
Yep.
I will. Yeah. He's got it. I'll put money on it.
No, I've never installed it.
So
No, I'm
so
saying
Ziggy,
I've got money on you being successful. Yes.
So it's showing you that you've got almost 8 dBi of gain on that spot.
on that one little sliver.
Right. But
around.
if you now go back to what you said was abysmal, get rid of the color, go back to the original screen.
Okay.
Okay.
Here.
Yeah. And look at that. And what does that say? -7.
Yeah. Looks terrible.
And that's my point. It's not -7. It is -7 where the
right
dot
here
is
in the middle. Right.
Yeah.
This is
going it's deceiving.
X, Y in the middle. It is deceiving. You're right.
So for anybody using this software, it's great software, but I highly recommend that you do the next step and you go to that color screen, move the line around, take a real reading at the hot spot that you want, and then you'll get a more correct answer. I mean, it's still modeling. It's not necessarily what is going to be in the real world, but it gets you in the ballpark.
This is it. Oh, you know what? My name's in the way. That's what it is. So if oh lordy, I'm not going to attempt this. But down, see my mouse cursor, guys? Behind my name, there's a little box here that says slices, and that gives you this thing. And then now we can actually pinpoint. I have never used this feature until now, and that's why I decided to live stream tonight.
Yep.
Because I needed guidance.
The other thing that I want you guys to all see is that as he goes up in frequency, remember this is a 160 meter wire. Okay.
And I'm pumping 20 meters into
and
it.
He's putting 20 meters into it. So it's no longer talking broadside to the wire. It starts talking off of the ends. It's acting like a beverage antenna.
Damn it, you beat me to it.
So
So if I hide
exactly
the
right.
pattern,
Yeah. Thank you.
right. So here's our dipole running from -Y to Y in blue down here, but most of the RF is running along it and not broadside anymore.
Right.
Because it's folding in on itself is what I like to say.
Right.
So I want to take all of my antennas, simulate
But
them.
look how many waves we have.
And each one, hold on, Chris, I hear you. So what happens with each of these waves, because it's on the 8th harmonic at 20 meters. So what's happening is there is a phase delay. If you start at the middle and you work your way out to one end, the first hump is a little bit of delayed. The second hump is a little more delayed and a little more delayed. And by the fourth hump, it might be 30 degrees off from the first hump. So those delays cause the signal to
Distort.
spit off of the ends and not be broadside. It's an interference pattern.
Yeah.
Okay, because it takes time for that signal to go down the way. It happens at the speed of light, but it still takes time. And so each hump interferes with the one before it. It's as though it's kind of like if you were to take your hand and cover up half of that dipole and figure in your mind's eye that each one of those humps is a vertical antenna, and they're all phased one behind the other. You now have a directional antenna.
Interesting.
Okay? Just a different way of looking at it. So in this case, the antenna is too long. It will still work. It will still make contacts, but it's not going to present the signal where you think it's going to go unless you do this kind of modeling and you really understand antennas.
So now, would an inverted V be a much more efficient antenna then with this design?
So great question. And when Ziggy comes back, we should do that. We should draw this as an inverted V to look at the pattern. So an inverted V traditionally is going to be more omnidirectional.
Yes.
Because each end is at maybe a 45. So there's still that phase difference between each hump. But remember now, the ones at the end of the wire are closest to the ground. So they're going to be reflected off of the ground. So depending on the height, where the end of the wire ends, let's say it's 30 feet above the ground. I'm making these numbers up as I go, just to paint the picture. Let's say that the fourth hump is 30 degrees electrically behind the first hump. But now, because it's an inverted V, that fourth hump is also reflected off of the ground. It goes down, it comes back up, it adds an additional 20 degrees to the delay. So now that last hump is 50 degrees different, not 30 degrees.
So
Does that help you?
So in doing an inverted V then would create a certain pattern.
Yes.
But what if you made it kind of the same squiggly coming down and you could shape it more? Would that
so you can shape it by adding reactance. You can add a coil or a trap or an inductor somewhere strategically down the wire. Okay, because a coil, remember Eli the Iceman, the coil is going to change the relationship between the voltage and the current, and the capacitor will also change it in the opposite direction. So you can actually steer it. You're only doing it for one band, maybe one half of one band, and then it all goes to crap when you go to the next band. If you dial this in for 20 meters, it's going to be terrible on 15. But yes, you can do precisely that, Chris. Yes.
So what if you put a whole bunch of traps in,
Mm-hmm.
like an end fed halfway,
Mm-hmm.
and you could dial in each band going all the way down?
You and I have been
How-
over this.
how
You're
success-
slowly
how successful
making
would
a
that be?
dummy load.
You can do it with traps, and it will work. So there's kind of two things that we're talking about here. So what I'm talking about is where is the signal going to go? And most people are not concerned with that. They're concerned. Yeah, it's exactly. It's a trap. Most people are concerned with
Isn't
the
that
match.
great? All right, so this gentleman won the stream right there.
Hold my
Won the
beer. I got this
stream.
one. It's a trap.
Yeah, it's a trap.
Dell's good like that.
That was pretty epic, dude. Nice.
So
good.
Most
points.
people use traps to get the antenna to get a good match to the coax, to the transmission line.
Not a good radiation.
Well, it will still radiate. It will radiate okay.
What if you made the traps like surface mount?
Out of surface mount parts?
Yes.
Is that what you mean?
Yes.
They won't handle any power.
What?
You can do it with milliwatts, but they're not going to handle any power.
It's like, say, like an antenna for 20 watts.
I don't think surface mount is going to handle it.
Even with larger ones?
You would the best way to do it would be you don't want to use ceramic capacitors. You want to use metal
Mica.
film, mica.
Metal film,
Exactly.
yeah,
Yep.
yeah.
Mica for the win.
Yep.
Yeah.
And you're better off paralleling a bunch of higher than what you want value.
For the
Okay,
cap.
so that they will handle the current, even at 20 watts.
Okay. Thank you.
Hollywood, I need help.
So do I.
Okay.
Take a
my
number.
help's easier than your
ahead,
help
shoot.
though.
Go ahead.
I don't see. I go to wire edit. Where'd it go?
Yeah, can you turn that into an inverted V?
Yeah.
Right. That
Oh,
was the
there it
next
is.
thing,
Okay.
Ziggy. Right.
I was
Paul, this.
All right.
He asked about an inverted. Can we take that and draw it as an inverted V and then look at the
We
pattern?
can, and the reason why I went to wire edit is because I want to look at said wire, and I want to reference the length, right?
Oh,
So the
okay.
whole length is 45 meters
Okay.
from y1 negative 45 and y2 plus 45. So it's 45 meters plus 45 meters, which gives us 176.6 meters. Does that sound right? No. What's going on here?
If you just
45 and 45 is 90.
Yeah, right. It'll say in the upper right hand corner if you snap on
I
that
know.
line.
Marine Corps mount.
Oh, you can't see
Right.
the damn logos in the damn way. Let me delete that. Sorry, guys. Okay. I just wanted a reference before I went to go drawing this inverted V of how long I need to make this.
Did you
fundamental
delete the
160.
previous antenna? Is it still there, or did you get rid of it?
This thing?
Yeah, that's it.
Still.
Okay.
All right.
Can you just
All you
make
got to do is go into wire edit
Okay.
and divide that wire by 2.
Ooh, that's a right-click function. I remember.
Yeah.
Wire definition.
Down. No.
It's at the bottom. Sorry.
Mm-hmm.
Divide wire into 2 pieces. Bam.
Yep. Okay. And now just bend one over the other,
What do I
or
do?
raise
Move
the
it?
center up. Yeah.
Can I grab it?
Yep.
Oh, I gotta grab it with this though, over here.
No, that's drawing a new wire. No.
that's
You had it
drawing?
right the first
No.
time. It's the one on
I
the
need to
left.
Edit. Okay. I can just drag that thing.
Just pull it up. Mm-hmm.
You're kidding, really? Shut up.
Oh, would you
You're
look at
kidding
that?
me? Are you? It's that simple?
Mm-hmm.
And the wire length's the same? No, it's not.
No, the length is a little longer, so you just tuck the
Okay.
2 ends in. Just drag each end in a little bit.
Yeah, but by how much? Should we just model it first and see what it does?
Just grab the one on the left. It
Uh-huh.
shows you what the length is in the upper right-hand corner.
It does.
I can't read it because it's too small.
It is 51 meters.
Okay, so just drag that point to the right a little bit.
43 meters.
Good. Do the same on the other one. Get them identical.
Okay.
Done. That's it.
Okay.
Bam.
You wanna
Look
rate
at
it?
Now you got to
that.
change. Just change the feed point. You see, it's in the middle
it's
of
over
wire
there.
1. So
That's in
go to the
geometry.
end. I believe it's the end of wire 1. is what
Wire
you want.
1. Ooh, I know this. You taught me. Wire 1 beginning. Or actually, and when it's on the wrong side, it's wire 1 end.
Yep.
And look at it. Ta-da!
Yep,
What is this
you got it.
little dot here, though? What is
I don't know.
that's
You've got a
the-
load there or something. Go back to geometry, the first tab.
Okay. Uh-huh.
See, you've got loads on the bottom
Loads,
right hand
I
side. That
do.
whole
You-
section. Get rid of
Need to
that,
delete that. Yeah.
Yep.
Delete.
and then unclick Use Loads.
Unclick use loads.
Hmm.
Ah, that's so
Now look
cool.
at it again, and that X will be gone.
Ta-da! And then we are going to radiate this at 1.5. Let's start it, and let's look at currents. That's
Right.
pretty good. That's not bad,
So now
actually.
to answer Paul's question, right? Exactly. You're looking now at where is the field going?
You want me to go
So-
3D, or you want to go
Yeah,
flat
go with the
far field?
3D. Go with the 3D
Okay.
because I think it's more telling.
These
It
youngins
shows.
need that 3D.
Oh.
Beautiful.
So it didn't radically change at 160 meters when we bent the exact. That's my new song, right?
Do-do-do. My man again. Do-do-do.
So it's still envis. The pattern didn't change, even though we bent the ends down. But now, instead of feeding it 160, let's feed it 20 meters again.
Yay!
Place
Let's
your
make
bets,
it
boys.
weird and awful. That's my
Well,
favorite thing to
and
do.
I mean, that wasn't horrible compared to the last
No,
one.
not
It was
not
very
bad
much
for
the
160.
same.
That's
It
kind of
was
what you
very
want,
much the
actually.
same, right?
Go Farfield. Ooh, it got super weird. It's not bad though. Look at that. That's
No,
not
it's
terrible.
symmetrical. That's a good thing.
Yeah, that's not terrible. I wish it would just run this automatically over here. But holy hell!
But look
God
at
forbid a cloud goes over you.
okay, but
during
look
the
at see the blue wire? See the blue wire?
Yeah.
Okay.
Here, I can actually take that away. Well, no, I can't. The blue wire. Yep. So I'm gonna make it sideways. Here's our antenna, guys. Flat, flat, broad.
Look where the current is going. It's going
going,
broadside and it's going up and out, but it isn't feeding as much off of the ends like it was when the wire was completely horizontal. It's a more standard pattern that we would expect from a dipole antenna.
This is not a bad radiation pattern, actually.
Correct. It's not. It's vastly improved.
Yeah.
It's
So you want to take your 160 antenna and you want to make it an inverted V.
Yeah. To do the harmonics. You're right, Paul. Exactly. Mm-hmm.
So here's, I mean, I hate 20 meters, and I'm not ashamed to say that. Let's calculate my favorite band.
What's your
15
favorite?
meters.
15?
15 meters? Yeah, that is the DX queen in my opinion.
Mm-hmm.
Nice little grab in between 20
Even
and
better.
10. Look at that.
It's got a null directly broadside to it. Right? Hold it steady there.
I'm sorry. Hands off the mouse, Ziggy.
So we're looking at it where the signal should come out. We're broadside to it. And there's a null. There's a donut hole there. It's going out, it's going up, and it's going off of the ends, not as bad because it's, bent down at a 45. But it's not going as you go up in frequency. We were at 20 meters before. Now we're at 15 meters, right? So we're at an even higher harmonic. And if you go to 10 meters, it'll be even worse. It'll again start shooting off of the ends. The higher up, the more harmonics you go, the more of those bumps in the wire that we looked at, the current, they will interact with the one before it.
But
Ziggy didn't pay his bill.
In theory, right? I mean, you're setting this antenna up in the wild. You would want to orient your wires a much more, like 60 to 80 degree freaking kind of angle.
So,
right.
Yeah.
I'm talking the cardinal directions, right?
Yeah. Right.
To really get a more east-west kind of broad coverage.
Right. If you can aim the wire, not broadside, but if you can aim it at the station you want to talk to, you want to talk to Europe, and the wire runs east-west, and you're on the 10th harmonic, it's going to act like a beverage, and it's going to talk off of the end of the wire, and it's aiming now right at Europe. Very little signal is going to the North Pole. Very little signal is going to South America. It's going to Europe, and it's going to the West Coast.
So if your antenna is in the wrong direction, change frequency.
Yes.
Or you could move the wires and point it, which is what I would like to simulate all of my antennas
Exactly.
So that I know like what angle if I want to make a targeted contact, I want to know what angle I need to be off of the ends or off of broadside in order to help make those contacts. And so I want to simulate all of my antennas in different fashions.
And you can do this if you have a wire antenna. You can run, Whisper or something like that, and look at the different bands and where does the signal go. Did you get them, Paul?
Almost.
They're good eating.
Or even FT8. FT8's awesome for just checking out where you're being heard and
I have something to say about FT8 for anybody that's watching.
It's lazy man's radio.
No, FT8. To taught me this, right? FT8 is basically this, right? I'm Ziggy. 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 I'm Ziggy.
Yep, pretty much.
Ziggy. I'm Ziggy. I'm Ziggy. I'm Ziggy. Yeah, you're gonna hear that, dude.
Yeah.
Mm-hmm.
Because it's saying what it is over and over and over and over. It's not like this is KM4ZGY calling CQ on 5.2. Does anybody hear me any station anywhere?
No. It's just yelling into the air and hoping someone hears you.
Right.
And that's why having FT8 and running FT8 on your setup at first is a good tool to figure out where you're being heard.
Mm-hmm. It'd be cool if we could model this one.
Which one?
80-meter end-fed half wave. So it doesn't matter.
Okay.
It doesn't matter where you're
Let's do
feeding.
it.
It's an 80-meter wire.
Yeah, let's do this. Brand new.
Half of it was east, and then it bent 90 degrees with the other half running north.
Yeah. Like I want to do stuff like this and like figure out a way to like point the signal in a certain,
But Dell didn't tell us how high off the ground it was.
No, he didn't.
Right.
30, 40 meters. Hold on, help me. We don't want a 40-meter wire. We want an 80-meter fundamental divided by 3, right?
No. It's an 80. It's a 80 meters half wave is going to be 40 meters long.
40 meters. Okay, so here we go. All right.
And
so
this
here it is.
software runs in metric.
Always metric.
Yep.
All right, so here we are,
So
and then let's go
so
to
48.
and let's make a pulse wire 1 beginning or end. It doesn't matter. Let's go ahead and do that.
So
Let's,
then it's
there it is. Perfect.
90
Let's
degrees.
calculate this for what?
So here's the thing.
45?
There is a problem with this software, which I think you will see if you look if you crank put it on view.
Okay.
And then expand the zoom on the left-hand side where you look at the current. Slide it all the way to the right.
It's slammed.
Right. So what do we see? There's no
Nothing.
current on the wire. There is, but we can't see it. Even though
We don't have the other half of the antenna.
Bingo. And that's and so this is the problem with this software. You have to fool it. You cannot give it an end fed without something to push against. So the simple solution for right now, no, I wouldn't even draw anything. No, just keep it simple.
Okay.
Keep it simple. Simply
He doesn't need the 90-degree line.
Right. Just feed it in the center. And it will solve the problem. Don't change the length of the wire. Just the feed point. Put it in the middle.
Put it in the middle.
Oh, we're making a perfect end fed. I gotcha. Okay, so I'll go to wire 1C.
Right. And now it will be a dipole. It's a doublet or a dipole. It's fed in the center. It's the same length. It radiates the same.
He also bent it halfway. So half was going east and the other half was going north.
Right. Now exactly, Chris. So now, Ziggy, you have to now go into the wire edit.
Yep.
And take each wire. So you're gonna take that one wire, you're gonna divide it into 4 parts.
Divide into 4 pieces.
Right.
Okay.
And now you're going to bend the last end down and the first end up by 90 degrees without changing the length of it.
Well, let me reference
Yeah,
the
so
length, which is
Now
gonna
you're just
be
making
what?
a swastika.
And I think that's what Dell has us drawing. Yes.
Wait.
Well, not
let me
quite. It's
see.
only half.
Okay, so length is
only
gonna
half
be
of it.
20
Each
20
quarter is
meters,
10.
so I need to go each
The
quarter.
whole
is
thing
10,
is
so
40 meters.
I
so
thought he was talking about just like an L.
I thought he was just talking about an L too.
Is that what we're after? That doesn't look right.
So one half of it went east, and the other half of it bent 90 degrees to the north.
I don't know if that's what we wanted.
but it
Hollywood.
doesn't say L. It's an end-fed half wave. So it's a half wave long.
Yes.
Half of
But
the half
Let's
wave
put this
wire.
back and let's
So
think about this.
40
and talk
meters
about
is
this.
going east,
Oh.
and 40 meters is going north.
Dell, we
Dell
need help.
says it was an L, horizontal.
Oh, okay.
It was a
What do I do?
horizontal
I'm
L.
lost.
So
Yeah. Yes, just like that.
Okay, so swing this guy down. Is that what I'm doing?
You need to do half of it,
How about I just
not a fourth of it.
Half
Can you
of
go
it.
back
Here?
and like divide it? No, can you go backwards and like
yeah,
Control
instead of dividing
do
into
half.
4, just divide it into 2.
correct?
So hit cancel, and that will undo the division part.
cancel? There's a cancel button?
Get rid of what you've got on the screen, that pull down menu. In the bottom right-hand corner, click on cancel in the bottom right.
Cancel. Got it.
Okay? So now we're back
Okay.
to the one piece. Or we were. I guess you
Well,
saved it.
Can you go back like a Control Z?
No,
I don't know
not
if
on
there's
this
Edit.
one.
undo.
Edit,
in
undo,
the
or
software.
something?
There's not.
Just draw a new wire.
Yeah, I'll just draw a new wire. That's Hollywood's. That's what I hear every time. It's just start over.
Hey, you know what?
Shake,
I'll
shake,
practice.
take the Etch-a-Sketch and shake it, and it'll erase
That's
it,
right.
and you can start over.
All right, so we are going to draw a 40-meter wire. Right?
Failure is
Ready?
just finding a way that it didn't work.
Oh, okay,
Right,
fine.
that's right.
Just put this right here. Shake it like an etch sketch.
There you go.
Doesn't everyone have one of
Roll.
these? Yes. This is
All right,
one of
so
the
here's my
original
40-meter wire, gentlemen.
Okay, now cut it in half.
Cut it in half. Let's divide into half. Okay.
And then fold one half 90 degrees.
Yes.
I don't think that's what we're after.
That's what
Yeah.
that's what we're after. Yes.
That's exactly
just-
what we're after.
It's
On
I
a,
mean, we're just making a
on the
dipole,
horizontal on the
Are we just
horizontal
making a
plane.
dipole? Whoop, I'm drawing. Sorry.
no, it's an end fed, but half of it is like going east.
Select.
Did he say which side the end was on? So
I'll tell you how I would
The
do
other-
this. I would just make a
He doesn't
counterpoise
sh-
wire off of this, just so
You
that
don't-
it had something to load
Ryan's-
against.
Ryan's reminding you got to put the feed point in the center to balance it.
Yeah, I thought we were infetting this.
but to get around the end fed problem with the software,
Correct.
you have to
Yeah.
put the
As Hollywood
I would
explained.
just
Yep.
put a little counterpoise on it, but okay. Let's undo that. All right, so what am I doing, guys? Sorry.
You're taking half of it and turning it 90 degrees.
Half
it-
to 90.
So it makes
Right.
a corner.
So the
Got
other
it.
thing, Paul's right. The other thing that I see, though, is that, Ziggy, when you were doing the wire edit, you were
Mhm.
looking at, I think it was XZ.
yeah.
I was in
so
the wrong field.
You want to be looking at XY.
XY.
Right.
Okay, so I'm in the wrong plane.
Yep.
All right.
So bring the half straight. Maybe.
Oh yeah, because it's on.
So
the
you've got to go
horizontal.
to, yeah, right. So you've got to go to wire edit, go back to XZ where you were, and fix
And
that
fix it.
wire, put it back horizontal,
Just start a new wire.
No.
and you
we're
can
not-
do that
no,
too.
We're going to
Yeah.
fix it. We're doing it
And
live.
Now go XY. Is the soup ready yet? We got enough chefs.
All right.
Yeah,
Is that better?
I'm so glad I jumped on this stream.
That doesn't look right at all.
Nope, that's what he wanted. Yes,
That's it.
Oh,
that's
You're
it.
there.
really?
Yeah.
Yep, that's it.
All right. So
You
do I
fixed-
need to feed it
you fixed
here,
it.
or where am I feeding
Yeah,
it?
in the middle. Yeah.
In the
You-
middle? Okay. I
To
can
fix
do that.
the software issue.
Right, because the current is going to be the same.
All right. So we have no pulse, so we're going to go to probably wire 1, maybe.
Did he
in?
say that he had a
Let's see where
counterpoise on it?
There we go. Okay.
Like, is there a counterpoise on this thing? Because that would be an interesting thing to know.
Do that.
Well, I
We'll
mean, if
do.
we're
That's a
center
good
feeding
point.
it-
Which way the counterpoise went, and then you could then
Right.
like
Okay.
you would probably use the
And
coax,
Del, what-
13-foot
So-
What
counterpoise.
frequency were you using? What band when you were feeding this 80-meter wire?
Like, what was the shape of the coax, and how long was it? Then you would probably be able to model it with the coax being essentially
Yeah.
the counterpoise.
Yeah.
Okay. So what? Let's look at where the wire is here. All right. So this is basically like a 90-degree on the ground wire.
But he said it.
I think what
it
you guys
was-
were after was an inverted L, right?
No.
No.
He had it. One side of it was pointing east, the other side was pointing north, and he said that it was a laser beam to Europe.
But he also had a 13-foot
On the fundamental.
counterpoise
On the fundamental. Let me
going
change. Let me
straight
change
down,
the
he said.
frequency. So this is
Okay.
So let's go to 3.5 because this is the fundamental of the.
So put in
Um,
a counterpoise of 13 feet
Oh look!
going down.
Look at that. That's not bad. Hold on. We're
80
getting somewhere.
through 10 with a manual tuner. That antenna was a beast on 15 to 40 meters.
It's a little oblong. All right.
Did you put the counterpoise?
What count? Sorry. This is hard, guys. It's not easy. This is not easy. And what is this antenna, first of all, that you guys have me drawing here? It's like going east
So-
and west.
Yes,
It's
that's what
it's a quarter. It looks like a damn quarter wave on its side. Am I?
He
said it
was
it's
a laser
half wave
beam.
fundamentally, and then a quarter wave on its side.
Yeah,
he
it's
said it
north
was a
and
laser
east.
beam. Yes, north and east. And so,
Okay.
what side did he say the feed point was on? Did he say?
Probably at the end of one of these. So let's change the
Well,
feed
yeah.
point, right?
Right.
To
We need all
wire
the we need
one
all the
beginning.
pieces. Right.
Yeah.
Right. Let's go to wire 1 beginning. Make
So-
sure my thumb's
Yeah.
at- There
Let's
you
try
go.
to figure out
Let's run this.
like why this was a laser beam to Europe.
Let's run this and see what's going on here.
But I don't know that
No,
the
it's pretty
counterpoise
as-
is going to change anything. But said he had a 13-foot
it'll-
counterpoise hanging down.
It'll play to the radiation pattern.
All right. So let's start over from something that I know, right? So I love a 5/8 wave antenna because it has a full half wave on top of it, and there is a little bit of current mismatch, which our LC circuit takes care of for us.
Mhm.
We cannot actually infed a true half wave. Is that correct, Hollywood?
Yeah.
Because the
It will
impedance is infinite.
No, it's not infinite. It's about 2,500 ohms.
Okay.
It's a 49-to-1 ratio. It will take power. If you're doing 100 watts, a couple of 100 watts, you can do the transformer thing. The reason why I say no is because I come from broadcast, and I know that's very different. But if you're putting 10,000 watts, 50,000 watts into it, you're asking an awful lot from the tuner, and the tuner has to be so overbuilt, and it's going to arc. It's going to have problems. So that's why they extend it a few degrees longer or a few degrees shorter. And the example I used when Ziggy had his last video with me was a 180-degree radiator, a half wave. It's a true half wave.
You said that was
The analogy is like trying to balance a pencil on the tip of your finger. It's unstable. You can do it, but you have to keep moving your finger because that pencil wants to fall over. Okay? So you can do it, but it's not easy to do. If, on the other hand, you grab the pencil by the eraser and you let gravity pull it down, you can wiggle your hand left and right, and the pencil stays with you. I know you're holding onto it, but it wags, and if you stop your hand, it stops wagging because gravity's pulling it down. It's a very stable situation. That's like the quarter wave.
Gotta love gravity.
Yep. So you can, if the load, it doesn't matter what the impedance is of the load, you can always use a tuner or a transformer to change it and match it to the transmitter. But what you have to understand, and I'll put this in Ziggy's terms, okay? Every time you change direction, you lose something. When you measure you got a hot rodded car and you put it on the dyno, what do we say? It's X number of horsepower at the rear wheels. We don't say it's X number of horsepower under the hood. It's at the rear wheels. Why? Because there are losses as it goes through the transmission.
The rule of 20%. Yeah.
Yeah. It wastes something. So
where the rubber meets the road.
Okay. So this is the point. So that when you add a transformer to match 50 ohms all the way up 49 times up to 2500 to feed that end-fed half wave, there will be a loss. It may be acceptable loss. That's okay. I'm not throwing it under the bus. I'm just saying, but
advantageous.
You have to understand that you're going to lose something.
All right. So this is our typical
1 hump or 2
half wave.
Right.
I'm sorry?
No, go ahead.
This is our typical in-fed half wave with a little bit of a counterpoise, which is absolutely necessary to make this happen. And so here we are on a fundamental, right? I think this is.
It's not. It's not.
Meters.
If it's the fundamental, it's going to have 1 hump. You're at the second harmonic.
Right. So it's twice as long that it needs to be.
Right.
Okay. So let's go and.
What band are you trying to work with this?
80 meters.
Okay.
Calculate start. Far field. No, view. I'm sorry. What's going on? Oh, I'm back to 14. I don't know why it snapped to that.
Go to the first tab. Go to geometry.
There it is. I got it.
If you go to geometry and you tell it at the top, see it says frequency at the very top towards the right hand side.
Oh, I can actually read
it's set for 14.
That's what it'll snap
the software defaults when you draw a new wire. It always defaults to 20 meters. But this is your opportunity to change it. And now when you do the calculator, it will default to whatever you set it to now.
Got it.
For that one antenna.
All right, so that's the root is in the geometry, not the calculate tab. That's where you get to play.
Yep.
All right, so if we go to view, all right, perfect. This is exactly what we were after.
That's a perfect end-fed half wave.
Hey, did you hear that?
So now he said that it was bent halfway down the radiating wire, and the counterpoise was hanging straight down.
So do the counterpoise first, because that's the easier one.
What do I need to do? Swing it down?
Straight down. Yep.
Straight down.
Okay. We're going to take this and move.
Make sure that you're in the right view. Wait, nope.
XY, not Z.
X,
right?
No.
No.
To go down, it has to be in Z.
Z, okay. So XZ. Nothing changed. That means we're in the right path.
Right.
Okay.
Now save it and look at it. Right. So that's correct.
Yep. There you go.
Now we do the second half.
Hold on. Let me put this in your folder, Hollywood.
Okay. I got my own folder. Wow.
On my desktop even.
We all got folders, I think.
Wow.
We all got files on us.
My head's going to swell.
All right. So I think
not only do you have a stellar voice, but you're super fucking smart with antennas, man.
Thank you. Thank you. I've played with this stuff for for too long. And it's simple to me because I've seen it for so many times. But yeah,
That's all
So
right.
this is
because
interesting,
you're
right?
passing your
Normally,
experience on.
and that's the goal, Paul. Exactly right. This is I can't take it with me. Got to spread it around.
Yep. Spread the love.
so this is
Share it,
interesting,
share
right?
it.
We normally think of right here as the high current point and where all the radiation wants to start, right? Like,
Mm-hmm.
but here we are in the fundamental, and if I take away the beautiful
Mm-hmm.
pattern here,
I don't agree with the
Hollywood,
software.
please explain to me why
Yeah,
we're starting at the end of the
anomaly.
wire.
That's an anomaly of the software. That's not correct.
Right.
That bubble should be in the center of the horizontal wire.
Yes.
Yeah, here. I agree.
So what if you bent that 90 degrees?
Let's go back and see what it does otherwise.
And I think part of the problem is, and this is an easy fix, Ziggy. The wire, if you look at it, it's the middle of the wire should be where X, Y, and Z all come together at that point.
Oh, I see what you're
Okay.
saying.
So
Yeah.
what the software
That
is
always
doing
messes
is
me up.
it's measuring the bubble from that X, Y, and Z junction, which is
Mhm.
Well,
which is at the end of the wire. So
Let's do
all
what
you
I
have
know best.
Yeah.
So here's here's 0, right?
Yeah.
Yeah.
All right. So we are going. Let's draw one. We're going 40 meters.
Oh my
this
God, are
way.
we starting over?
We
No,
are.
I mean, it takes
Oh
2
no,
seconds.
this was so simple to do.
It was.
Okay.
It takes.
All right.
Yeah, we're 40 meters over, and we got us. Yeah, which is fine.
It's still
Okay.
not right though. It's still not right. You want the
Oh.
middle of the horizontal. Okay, stop. Let me show you how to do this. Don't draw it.
Okay.
This is
All right.
easy.
Okay.
Get out of the screen. Hit cancel.
Yep. Cancel.
Look at the view, which you are.
Yep.
Okay. So it's really tiny print. It's hard for me to see. But the horizontal wire, is that on the X or on the Y?
This is X.
Okay. So if you now go to, don't click on it, but just look with your finger on the screen where it says calculator.
Mm-hmm.
If you go up and 2 clicks to the left, you'll see a diamond. 2 clicks to the either that one right there. That says move.
I can move
click that.
the whole antenna
Yes,
in free
yes,
space?
yes, yes. Click there.
Fucking learning new shit, man.
We just save 15 hours of time.
You broke him. You broke him.
Poor Ziggy.
All right, let's go.
He's like
but I have
Popeye.
to
He had
tell
his
it.
spinach and he's ready to go.
Let's
All
go.
right,
All right, so we need not X, Y. We need to go Z up.
No,
by,
not Z.
No?
Not Z.
No.
Z is up and down. You want to
Right.
move. You want to walk the wire. Again, I can't see. Is it X that it's on the horizontal
It
part?
is. It is. Yeah,
Okay,
the long
so
wire is on
You
X.
want to go negative X.
Okay. To the middle.
I don't
So
know.
40 meters?
To the 40 meters, and then there's a 40 meters running.
Yeah.
In the
Okay,
wide
so
direction.
So look at what it did. It moved it in the wrong direction.
So we
We're away from the junction. So go back to what you were doing and go.
Mm-hmm.
So if you did negative, go positive by the same amount on the X.
That was on X, so we need to go 40 up.
Yep.
Oh, shit. Negative 40. That brings us here. And let's do it one more time to get back to center. Negative 40. Whoa. Negative 40.
Yeah.
And
Okay,
one
now
more time?
now do
Now
half.
negative 20.
Right. Yep.
Negative 20. Hey.
You got it. Home run. You're
read
there.
it?
Yep. And
Oh,
now that bubble
look at
should
this,
be right
20
over the
meters
center of
again.
the
What
wire.
shit?
No,
'cause
it's fine.
I started over. I threw it all away. That's right. 3-5, 3-6, 3-5, and 3-5. Why can't I run? Oh, I've got no. I didn't do.
I mean,
my,
this is a
my pulse.
disease. I need to tell you where my head is. He said, "Throw it all away." Now I hear Miami Sound Machine singing, "Don't throw it all away," right? And I got the other song. What the? Don't throw it all away on love. On love. It's with Bee Gees or something, right? I can't help it.
Yeah.
So distracted right now. You're hilarious, Hollywood. Geometry. I need a pulse. I need a wire one beginning. Hopefully, I
Right.
did that correct.
Mhm.
Let's view it. View it. Yep, that's it. Run it.
Run it.
3-5. All right. 3D far field.
Okay,
5
so we still got the bubble, but it should be in a different location.
It should be right over the center wire, and it is.
Hey, that
Yeah.
looks right.
Yeah. So what did we learn?
Did it.
It's a problem with the software. It always wants to draw the bubble at the junction of X, Y, and Z, no matter where the wire is.
Huh.
So don't trust it just because the bubble is offset. Doesn't mean it's right. Okay.
And look, it's properly broadside
Yep.
to the wire.
Yep.
Put your wire in the middle, boys.
Okay, so now we're gonna make the other
Yeah.
side of. So
Yeah.
you did 20.
Corner.
You need to move that
Yeah,
another
right.
20.
Paul's right. So now we want to bend that horizontal
Oh, we
wire.
got to get closer to the current side.
So
right? The beginning. So let's do it
it's-
again. Is that what you want to do?
It's 40
No,
meters.
no, don't start over.
Don't start
No.
over.
What?
Just go
Damn
back to your horizontal wire and split it
Okay.
in two.
Well,
bend it 90 degrees.
hold on. He said it
I don't
was
know. This
an
looks
80
good.
meter. It was an 80-meter wire. Half of it was going east. Half of it was going
Hey, Andy.
north.
Right.
And
Just
so
split it in two and
right now
bend
you're
it
at
90
a 40
degrees.
meter, but you're at a 40-meter wire. Okay, so you're gonna have to move your antenna another 20, so it's 40, and then add another 40-meter wire to the end of where you have your X and Y. So it'd be 80 total.
So just draw another 40 in a 90 on the y-axis off
Correct.
the end of the current horizontal.
Yes.
So because I'm
understand?
a in-fed homegrown antenna especial, what I'm looking at right now is actually the perfect in-fed. Right? There's a little bit of current on your feed line or your
Right. But we
counterpoise,
wanna-
whatever you want to call
We
it.
want to know what Dell's antenna
Right.
was
We're
doing.
creating what Dell. Yes.
Yeah.
Exactly.
So he had an 80-meter wire. You're currently at a 40-meter wire, and the origin it needs to go another 20 meters so that it's at the end,
Okay.
All right,
So
So-
and then
let's
you're going
move
to
it.
add 40 more to it.
don't
All right,
draw.
well, let's move it.
No. Stop. Stop. Stop.
Stop.
So So Chris is right. It's a 40-meter wire. Let's do one thing at a time. It needs to be an 80-meter wire. So you don't move the wire. What you do is there's another button. So get rid of this one.
Gonna break him again.
I know. I love it.
This is great. This is great.
Should I save? Can I save right now?
Sure.
All right, let's save.
That's a good practice. Save it right so that you can always go back to it.
This is Dell's antenna.
Yes. Dell may need a new folder. He may need a folder of his own.
Dell.
Yeah. There should go in
Next
both
time.
folders.
No, he has to come on stream to earn a folder.
Okay.
The link's in the chat, Dell. Anyway, let's continue.
Okay. So now we're above calculate.
Mm-hmm.
There is a button there that allows you to change. I can't see it. No.
we've got
It's one of those
move,
first four. What's the third one say?
Move, reflection, rotate, wire scale.
Wire scale. You
Wire
want
scale.
wire scale.
Okay.
Oh.
Okay.
Ooh, this
So
is a
this
new
is-
window. I've never seen this one.
But that's why I'm here. Okay.
That's
So,
Why I did the stream.
So you're gonna times
Oh.
2 then,
yes.
but
Correct.
then the counterpoise would be wrong.
No, it's going to fix them both. It's
Boom.
going to fix them both. You watch. It's
Is that
done. It's done.
Run it.
Now run
Run
it
it.
at the correct frequency.
I think I'm at the correct. Did it run?
No, you're not.
Yeah.
It's
80
an
meters.
80
Uh-oh.
meter.
Whoa! What happened there? Oh, it divided the frequency.
Yes.
Look at that
yes.
shit.
Yes. But just run it at 80 and confirm that the currents are where you expect them to be.
I ran it. I don't have currents. Run it, bitch.
I didn't see it.
It won't run.
Hmm.
Why won't it run? Let's go to geometry. I've got a pulse. I've got a feed point. I've got a wire. I've got a counterpoise. I got a frequency.
You know why? The counterpoise is too long and it's below ground. So elevate, add height
it's
to
that
it.
again.
Yeah, add height to
That
it.
again. Yeah, you can't.
Now
make
you're
it.
okay.
Oh,
Now
it ran.
There
Look
you
at
go.
that.
There you go. Now look at
There we
view.
go.
Look at view and just confirm that the current is in the dead center of that horizontal piece.
Let's see. Oh, sorry. Let me get out of here. We don't need to be here. This is all proper and everything, but we'll get back to this in just a minute. All right. So here, and let me exaggerate.
Okay, so
that's all the currents that I can zoom. It's not.
Now we need that 90-degree bend.
Yeah.
okay, so but this is showing that the wire is twice as long as it should be. Let's just confirm. You're at calculate and you're running it at 80 meters. Go to calculate, Ziggy. Put it on 80 meters.
Yeah.
Again, I can't see it. Is that 3.5 roughly?
3.5.
3.6?
Yeah.
Yeah.
Okay, fine.
355.
Run it again.
Okay. No fatal errors.
Go to view.
Yep.
Okay. So, okay, here's how we fix it. Go to geometry.
Yep.
At the top where it says frequency, put it at 80 meters.
Okay. Oh. Okay.
Now go to wire size.
Where the shit is that, Hollywood?
It's the fourth one over. It's above the E on calculate. It's the one we just did. The last one we did. One to the right. One to the left.
The scale.
It says wire scale.
Wire scale.
Yeah.
Okay.
Like fish.
3.5.
Okay. So now, okay. So this says 160. So bump that down to 80 meters. So the new frequency will be 80 meters.
New frequency. I mean, old frequency and new frequency are the same at 3.5.
So then, okay. So then the new frequency will be 7 megs.
Okay. 7.1.
Hit OK. Calculate it.
Okay.
Make sure that the frequency is 3.5. It is. Look at view. Go to view.
Okay.
Go to view, not field.
Sorry.
Go to view.
Sorry.
Okay, perfect. You got
There
it.
you go.
You got it. Now save that
Saving.
because that's correct now.
Yeah. And now you're going to then fold it and
Right.
divide it by half and fold the half 90
Okay,
degrees.
so now we have a known good. So now we can go to wire edit. And we take that horizontal wire and we divide it into 2 pieces.
I don't think you're in the Z. You're in the Z.
Right. Good catch.
Good catch.
He's right. Yep.
I don't think dividing it was going to
Divide by 2.
Divide by 2, yeah.
Okay. Now, when you go to wire edit, you can take 1/2 of that horizontal piece and you can spin it around in any direction you want.
So
I'm in XY. What do you want me to do from here?
Don't bend it in the middle. Take the
Right.
end.
That's right.
grab the one on the right. Grab the one on the right, yeah.
Okay.
I think that's what was at the end, right?
And what are
Yep,
we
and
doing?
then fold it so that it's going up.
Here?
Yep.
Okay.
All right.
Hit
Jump out.
okay. Yep.
Yep, that's it.
Run it.
Calculate
Yep.
it, run it. Send it.
Send it.
Yep. Ship it.
Oh, God damn it.
Wrong button.
What the shit did I just click on? Windows 11.
You got Windows
What
11
the
issues.
hell?
Mission failed. We'll get them next time.
Hey.
There you go.
Uh-huh.
So now it should be a lobe
It's
going.
still very invis though.
No, but I can see why it was a laser to Europe now.
Uh-huh.
That makes sense.
Uh-huh.
Look at all this purple off to the sides though.
So so it's too low to the ground. Remember, it's bouncing off of the ground, it's going NVIS. But it changed the angle of the jelly bean, if you
It
will.
did.
It's still
It
going
sure
up,
did.
but it spun it
there's the
around.
counterpoise.
Right.
We
That's
went
the
this way
key
and
here.
that
That's
way.
the key.
And
Yep.
now all of a sudden we have a new angle that was not
Mhm.
achievable before on the fundamental frequency.
Bingo.
Yeah.
Yeah. Now, if you want, you can add elevation.
Let's
So
do that.
double whatever you have for elevation there, double it. And then let's run it again.
We are on real at 60 feet up in the air. How high
No,
do
it's
you wanna
those
go?
are in meters. Those are always meters.
Right.
software
20, 40,
doesn't do
60
feet.
times 3. Yeah, it says 20 meters here. Sorry.
Yeah.
It says
but
20
that's-
meters.
Oh, okay. You did it in your head. I got
Yeah,
it.
yeah.
So make it 40 meters up in the air.
Del says about 30 feet up, so that's 15 meters.
Oh, okay.
Well, but the counterpoise
Wait,
is
hold on, not half,
also
hold on.
Right.
double the
30
length.
feet up.
The counterpoise is double the length. So
Chris
you
is correct.
Counterpoise is
have
the-
to decrease the counterpoise.
The bottom end of the counterpoise that is closest to the ground, that is what the software considers to be the beginning of the antenna. So when you add 20 meters, it's from the bottom of that counterpoise up
Of this
to
guy.
the ground.
Yeah.
Yeah.
So that needs to be 13 feet. So do a wire edit. And edit
Yep.
that. So that it's half of whatever it was.
If you edit the counterpoise, you're going to
Mhm.
change.
There you go.
You're going to change the radiation of the whole and the impedance of it.
Yeah.
What I'm suggesting
And-
is that you use the elevation. That changes everything together.
But if you change the wire, then you can change the elevation and bring it down to what'd you say it was, 30 feet?
Yes,
Well-
you can, but then it won't be an end-fed anymore. You won't have enough tail. You won't have enough counterpoise if you
That's
shorten it up.
But
So-
we're just trying to simulate
Oh, okay.
Delphargus's
Okay,
antenna here. So
we're recreating what he. Okay, got it.
yeah. Because he said it
I
was
mean,
a laser
that's
beam
great that
to-
we're trying to
to Europe.
recreate his antenna here, but I'm trying to follow Hollywood on his instruction as to what we're doing.
Sure.
I'm going to sit on my hands. I think you're doing fine.
You're
You're doing good.
doing fantastic.
So,
So decrease
So,
the
I can't-
counterpoise.
okay, sure. Z. There's my counterpoise, and let me select it. And my counterpoise is currently 9 meters long.
Yeah, it needs to be 13 feet. So what was that?
27.
2.5?
2.5 meters.
Is that right?
I can do 2.5.
Yeah. A meter is roughly 3 feet.
No.
and
so,
change.
so it'd be
Let's
3.
go 3 meters. 3 meters
Yeah.
is fine.
Yeah.
Yeah. Okay.
And then he said the entire antenna was then 30 feet off the ground. Is that right? So
We
decrease
moved
the
it
whole,
to-
move the whole antenna down. It was at 20. It needs to be at 30 feet.
Well, let
Which
me.
would
I
be
mean,
10 meters.
you want 10 meters of height,
Yes.
and the
Correct.
lowest point would be the. Yeah, that's pretty practical. Let's
Yeah,
run that.
as long as it's above the ground, that's fine.
Yeah.
It'll run the software. Yeah.
Whoa! Look at all that current, son.
Mhm.
Wow.
Let me turn that down.
Mm-hmm.
All right. Let's go to 3D and let's look at which way it wants to favor.
So, so the blue,
Very similar
or the
jelly
Blue's
bean.
here.
Right,
the
Paul.
red,
Yep, that's
the,
right.
the red with the counterpoise would be pointing east, and the blue 90 from it would be pointing north, and so the broadside of it would be going to the broadside of the the bean here would be then pointing towards Europe.
It's pretty
Right.
slick if you think about it, right? If you're really interested in like that one fundamental, because I guarantee I changed this frequency and it's going to become a mess.
Well, let's do that. Look, we're
Yeah.
feeding it at 80 meters. Put 40 meters into it and see what it does. So it'll be the second harmonic.
I mean, pretty much.
It looks like it's still got a pretty good jelly bean.
And try to picture in your mind what you think it'll. Okay.
Oh, wow.
It's much more envis.
Mm-hmm.
It's the complete opposite.
Mm-hmm.
Because it's been divided by 2, guys.
But he said it was a laser beam.
We went from this way, and now it's more so
Well,
this way.
all right. So let's try the other extreme, right? Because he said
Okay.
it would go to 10 meters.
Yep.
Let's go to 10 meters. And
There you go.
See this spaghetti.
Try to picture in your
Garbage.
mind what do you think it will do, and then push the button and see if you're right.
Oh
Yes,
shit!
actually,
That's
some-
not at all what I was picturing.
Well, that's exactly what I was picturing was going to happen.
Wow.
Is that
So
you're going to get
there-
this complete
There's your laser
dummy
beam.
load.
There's your laser
Look at
beam
all
to
this
Europe
blue.
right there.
That is the most blue I've ever seen from an antenna.
Blue on blue, heartache on heartache.
This is Dell says this is awesome. I accidentally made an input halfway directional. Holly and Ziggy are showing the theory. This is the best. Like I don't want to talk to you on the radio. I'll call your ass. But this is the fun, right?
Yeah.
Right?
The
Dude,
thing
this
that we
is kind of a cool
cannot
thing.
see.
Well,
It is.
We can't see RF.
what I would like to do is do other people's, like, you know, what is your antenna, you know, doing, you know, and like you can
Mhm.
help people
It's
with their antenna.
it's not you, bro. It's not you, bro. It's your antenna.
It's your antenna. This is what it's doing. This is why you're having a hard time. You just need to do this to it.
Here's another one of my
But
favorite.
so I would
frequencies.
imagine that there's other hams that like. I mean, so listen, I'm not a brainiac, but I'm thorough.
Oh, dude, this
So-
thing's a banger on 17 meters, man. You see
Like
this,
when I-
Hollywood?
Hold on, Ziggy. Paul's
Yeah.
going to make a point. Go ahead.
Go ahead.
So when I put my antenna up in my backyard, right, I strategically calculated the cardinal direction of the antenna based on the height off the ground.
Right.
Now, I didn't use modeling software. I just tried to figure this out on my own in my head based on what I had learned from YouTube videos and things.
Mhm.
Sure.
But it would be really cool, I think, to have different live streams where we feature somebody's antenna.
Yes.
We really go through it and understand
Mhm.
like
Mhm.
the way that their antenna is configured in their specific location and how it reacts with the surrounding area. I'm really curious to that.
Yeah. Yeah.
Oh, but there's also one more to it, this as well. So there's a software called FarLab that you can do the propagation and like the amount of hops going through the atmosphere and like how it if it's too high it'll go off into space and it has to be the right angle. And from this antenna you got stuff like a laser beam to Europe.
I want to mention the elephant in the room right here.
Mhm.
Yeah. You think your
That
radio's going to be
counterpoise?
happy with that coming back on the shield? Right?
But this
Nobody
is also,
wants to talk about this.
this is also a case where did it work? Were you able to get contacts?
Right.
So this is where the experimental part of what you like to do, Ziggy, is send it, see if it works.
I just like to be hypercritical about other people's antennas.
Sure.
The other
Nothing
thing
about
to
that.
keep in mind is that this modeling software is free, which is good, but
Yeah.
because it's free, it's not the most accurate thing in the world. It gets you in the ballpark. It is not the definitive answer, to the nth degree. Okay? So it helps you visualize and learn where the signal is going to go, but don't rely on it as being gospel.
It's not the
Yeah.
end all be all.
No.
Right, exactly, right.
But it gets you pointed to a good
Oh yeah,
direction.
it's very useful. I love it. I can spend winter night after winter night playing with the thing. House come home.
Now, with this software, can you orient based on the x and y axis the
Yeah.
actual cardinal directions?
That's what I want to do with targeted contacts is to model all of my antennas. And so if I need to make a contact, I can refer to like field cards or something, like use this antenna and set it up in this configuration type of thing.
Right, but is the software able to like give you that kind of orientation so that you can look at it,
Generally, so
as a zero north,
we've got
right?
this
And
configured in a way that it's the y direction is going north, south, and the x is going east and west.
Yeah, it's
okay,
up to you,
perfect. So
Paul,
you can
to
just change your
decide.
view.
Is exactly in your mind's eye. You have to say, is X the north south and the Y is the east west, or is it the other way around? It's completely up to you.
Gotcha. Thank you.
All the knowledge has come in from Andy Callie right here.
Magnificent.
Yes.
Thank you, Andy.
Brother
We don't
Andy
know
to
what
the
we're
rescue.
doing. So let's talk about what this counterpoise is doing for us specifically,
Right.
right?
The elephant
Because
in
you
the room.
can't,
Mhm.
you can't, you have to have two sides of an antenna,
That's why it's called a dipole.
right? Now, what I've done is I've modeled this
A fluff.
40 meters.
Suddenly a
right?
fluff.
Yeah, so we went from the fundamental of this thing, and let's go to its view. And it still has a high current because it has to have something to push off of.
Is it a Samoyed?
So,
It is.
Yeah. Beautiful dog.
what can you teach us about this counterpoise and what it's doing? And
Okay,
what
so look at the current directly above the feed point. So if you can
it never fell to zero.
Yeah,
That could be
bingo. You got it. You nailed it. That's it. That's it. So what I taught Ziggy, I'm going to share with you two guys right now, and anybody else that's watching. You start at the end, because the end is always the same. It's always going to be high voltage, no current. It's the end of the wire. So it's always a known, and then you work your way backwards from that to the feed point. So if we look at it, just hold it steady for a second. Let's just talk.
Hands
okay,
off. Hands off.
So the far end, that the blue line is current. It's not voltage, it's current. Yes. So it's zero current at the end of that wire. And as it works its way back towards where the feed point is, the current goes up and it falls back down because it goes through one half of a cycle, but it doesn't ever reach zero again at the feed point. It's hanging in the air. It's not complete. It needs.
Is that because the wire length is wrong?
Yes, exactly.
Correct.
Right, Paul. Yes.
So does this go back to the leading and lagging conversation?
No. The next question is this too short or too long?
It
would be too short.
I'm asking them,
right?
not you, Hollywood.
Yeah.
Oh, okay.
I would assume it would be too short.
Well, let's change that. Or let's change the frequency. Right? So if it's too short, let's make the frequency a little Help me out here. Let's just
Oh,
run it.
that would be more.
There it is. Boom. Nailed it.
You got it.
Yeah.
So what
Look
he
at
just did was change the frequency. That's a very easy way to do it. Don't redraw the wire. Just change the frequency. That's perfect. And now
Right.
you
So I
see it
went
does
from
the
3.5 to 3.7.
right. And now you
A
see
higher
that
frequency.
current has completed through one full cycle. And look at the current on the tail, on the counterpoise.
It's not worth talking about.
Right. It's minimal because it doesn't need it. It's completed the full cycle.
So
It's
this
still
antenna
using it
is
because without
very,
it, it
very
couldn't
good
exist.
at one specific frequency.
You got it.
No,
Outside of that,
So it's a
It's
high
let's run it.
frequency.
Let's
major
run it at the
compromise.
double. So 3.7 times 2 is.
You're correct, Paul. It is a what's the word I'm looking for?
Is this?
It's still going to be high impedance, but the reactance is nullified. It's close to zero because it's doing 1/2. But it's a complete cycle. Okay. If it's too long, then the reactance goes up. If it's too short, the reactance goes up.
So here's something interesting. So I took that frequency that we stumbled upon, which was what, 3.7?
Yep.
Mhm.
Let me run that and just start over. This is a beautiful configuration.
Mhm.
The fold of 3.7 comes to 7.4. Look what happened at 7.4.
Another good lesson. Perfect.
What happened?
Ask yourself.
supposed
I'm
to-
not going to answer. You figure it out. Why is it doing
I already know.
that? Okay, let the other two guys work on it a little bit.
But this is the key right here. See how we weren't actually going down there?
But you're almost.
This was the apex. It's actually going back up again. If I can zoom up on this a little bit. Do you see this?
But it's
this
also
apex?
not. It's also not going down to the wire as well.
Right.
So
why?
well.
Why?
So
Why?
is the height that it
has-
comes down to higher at the feed point than it is over there in the middle?
No, we're working
it
with this
further
weird
away?
wire that we're
But is
working
it
with this.
further away? Is the blue line further away from the antenna in the middle where the 90-degree is, as opposed to the feed point?
Maybe we should straighten this wire out so we can have a more basic view of what's going on.
Because I feel like there's something happening, like it's growing
So
towards one end of the antenna.
Now, I'm assuming that the current never reaches zero because it's a harmonic.
Exactly.
Yes,
that's part of
Right.
it, Paul. Yes.
Yeah.
but there's
Look at what Ziggy was. I won't give you the answer, but Ziggy was hot on the trail. Look at the blue curve, the end of the blue above the feed point.
Right here.
yeah.
And you see that it comes down to a peak and then it starts to come back up again.
It never falls.
But
Right.
that peak,
It will never lie flat at the end. Forget
the
about
peak-
that.
but the peak
That-
never touches the black anymore.
But that's okay, Chris. That's
okay.
You're correct. You're correct. But in this part of the lesson, that's not a big problem right now. What I want you to focus on is that it comes down, it nulls at the bottom, and then it starts to, if we really exaggerated it, it would start to draw up again. We can see it just starting to do that.
Yep.
Okay. That's what I want you to look at. So see if you can figure out, why is it curving back up? Why is the null not at the bottom?
I'll give you a hint. It has nothing to do with the fundamental wire.
That's is the apex of the blue curve getting higher as well?
Yeah, it probably is. But again,
yeah, it is.
But that's okay. That's okay. Just look at above the feed point.
Yeah.
It comes down,
And
it
then it
reaches a null,
goes back up.
and then it starts to come back up. And the question is, why is it coming back up?
If it's
This
half,
Ohm's law.
Paul's got it.
Ohm's
Paul's
law.
got it.
Go ahead,
Paul.
So, all right, you have more current, and so then you have more reactance, right?
Not necessarily.
Inductance.
Okay.
Hold on. You've gone. Go ahead.
Yeah. I don't. I don't know how to explain it, but I
It's
understand.
okay.
Let's go to the next harmonic times 2.
If I
over
made
for-
if I made that wire
Let's go to
even
20 meters.
longer, we've got a different screen. That's okay.
I'm sorry. I'll put it back. My bad. We were still trying to figure this out. Let me go back to view. Go ahead.
If I were to
Actually, that's
make
wrong
the
frequency.
horizontal part,
Oh damn it!
okay, so leave it right there.
I've lost it all to shit. Okay, leave it. I'll leave it.
Okay, so if I were to make the horizontal part of the wire longer or shorter, that would also change where the end of the blue wire, the blue line, whether it drops down at the bottom, or is it too short, or is it too long? Does it start to curve back up on the other side? It's the length of it's the electrical length of the wire, not the physical length. It's the electrical length, and the electrical length changed when we doubled the frequency. At the first harmonic, it was perfect. And when we went to the second harmonic, the double the frequency, now that current line doesn't line up where we think it's going to. And the question is, why?
Because our bands are not in
Well,
free space.
Yeah. And even though
Close.
you're very close. And even though you did the math that you doubled the frequency, exactly doubled it.
But it's not exact.
It is well, Paul, it is exact on the frequency, but the thing is it takes time for the signal to go down the wire.
So
that's called velocity factor.
Velocity factor. I was
okay.
Nobody likes to talk about that.
So can the
that
software
changes
model
the harmonic?
You can right here. Material loss, no loss. Let's go ahead and select copper.
Right.
Copper wire. Yeah. Let's run that and see what changed. Not a whole hell of a lot, because copper is a pretty great antenna.
This software is so basic, it doesn't allow you to add coding to the wire. It thinks it's bare wire. Okay. It doesn't know. It's not advanced enough to do that. But when you double the frequency, you are electrically making the wire twice as long. And it takes time for the signal to go down and propagate through the conductor of the wire. So every time you advance the harmonic, if you do the fourth harmonic, the eighth harmonic, the 16th harmonic, it takes progressively longer for the signal to go through the surface of the wire.
So it increases resistance.
It
and then
increases
there it is rising.
It increases the reactance.
Because
yes,
I had it right.
10 meters.
You're close. You're very close, Paul. Good, bravo.
Can you rotate
What do you
this a little?
Oh, it's garbage on 10 meters, man. I mean, not necessarily. I'm sorry, I take that back.
Okay.
The common mode is going to be garbage, because this is just
It looks
craziness right now.
What is so neat about this software that I absolutely love is this is what I'll share it again. This is what my mentor taught me before I was a ham. I was a CV
1 volt,
guy.
no current.
Yep, NC1V. And I've got the mag mount antenna on the roof of my Volkswagen.
No current.
And I'm tuning it for lowest SWR. And Richie comes along and he says, "What the hell are you doing?" He says, "You want to tune that for the most field strength." I said, "What the hell is that?" And he comes out with a field strength meter and he puts it up on a wooden ladder and he says, "Okay, now adjust the tuning, the tip of the antenna." So exactly, Ziggy, so that meter goes to its highest peak. The hell with the SWR. It doesn't matter. You can fix that with a tuner, but you cannot fix the field strength with a tuner. You do the field strength first.
Here we go.
That's
Here
awesome.
we're back to the perfect one again.
And
sorry,
I
guys.
fought with Paul. I fought with him for 10 minutes. You're wrong. You're wrong. He's an extra class. You're wrong. You're wrong. You're wrong. Well, he says, "Humor me. Try it." And lo and behold, I got another, number, an extra number on the field strength meter, and we're off and running. That it was proof positive.
It makes sense. Like,
Yeah.
I mean,
Yeah.
logically, like it makes sense.
So this is why when I mentor people and I tell them you're building an antenna from scratch, we've been conditioned, we've been taught to look and trust at the SWR and trim the antenna for the best of SWR. Your dummy load has the ultimate SWR. It don't talk nowhere. Okay? So okay. So it's sort of right, but it's not really right. The correct way is you build the antenna to put the maximum signal onto the target. You want to illuminate that target as much as you can. Then you can fix, once you've got that done, then you go ahead and chase the SWR with a tuner. You can add lump components, you can add capacitors and inductors and change things around and get a good match.
Now, so all right, when you're tuning an infant half wave, right, to not need a tuner in the field, obviously, I mean, it's all a compromise because everything is. But from my experience, what I know is that you tune it for 40. If it's a 40 through 10, tune it for 40, and then you can use it on the other bands. It's just not as good.
Right.
But it's still good.
Yep.
Well,
It'll
isn't
make
there
your radio happy, right?
Isn't there something
there's
that
a
happens?
coefficient.
Isn't there something that happens to an antenna after 40 that you have to account for?
The higher up you go, the more harmonics, the worse it gets. If you cut the antenna if it's an end-fed half wave, and you cut it for 80 meters, and then you go ahead and use it on 10 meters, it will not be resonant in the middle of the 10-meter band where you think it is. It's going to be resonant at it's going to be like 29 and a half megs. Okay? That's because of the velocity factor of the wire and because of the interaction with the ground below it. It's both. Callum DX Commander has a wonderful saying, and it's very visual. When a seagull is sitting on the ground, she's got her wings tucked in tight. As she takes off, the wing tips start to expand out, and by the time she's up in the air, she's soaring, and those wings are fully extended. It's the same thing with the antenna. The higher above the ground, just like the seagull, the longer you make the antenna. When it's low to the ground, you want to trim it back because it interacts with the ground. The ground electrically makes it longer than it would be otherwise.
I love you, Del, because you had no shame on telling the entire world that you put 11 meters into that sumbitch. You have a special place in my heart forever and ever. That's a true ham right there, ladies and gentlemen.
Yep.
Dude, I'm excited for 10 and 11 to start opening up again.
Yeah. So this is why on On an end-fed half wave, they
we
often
all
add
are.
a coil like a couple of feet away from the transformer. That lump constant, that coil, is changing the electrical length of the antenna on the harmonics. It has very little effect on the first fundamental and maybe the second harmonic. But by the time you get to 10 meters, it now has a lot of interaction with it, and it will shorten the antenna.
That's why we add a small inductor a few feet away from the
Right.
beginning, sometimes
That's
the
what I
end
just
of
said.
our
Yep.
fundamental. Right. Oh, I'm sorry. I was
That's okay.
reiterating. And what that does is it lengthens the antenna, because right here you can see on 10 meters we need a little bit more wire, right? Yeah, that's what that inductor is gonna do. It's gonna make this fall a little bit better, but it's also gonna do a little bit of band shifting as well. And it actually affects the next couple of harmonics down.
Right.
And yeah.
And it
usually-
becomes less effective. It does less and less the lower in frequency you go down to the main. When you get to the first frequency that it's cut for, 80 meters, it has very little effect there. Has a little bit of effect
almost
on
unmeasurable.
40.
Yeah.
Yeah, but it's small. It has a little
Right.
bit more effect on 40, has a little bit. By the time you get to 10 meters, it has a great deal of effect. It equalizes the antenna. It flattens out the match for each band.
Right. So it's high fundamentally, isn't it? Doesn't it normally like fall like where is it? Like 29.7, like way high.
Yeah, that's right.
And then you give yourself a little bit of inductor to electrically lengthen it, and that'll get you back down.
That's right.
Into where we want to be, into the the technician general sideband CW digital area.
As hams, we're asking an awful lot from an end-fed half wave. No, we really are. We really are. It's like,
oh, trust me.
If you take, did either of you guys play guitar? Anybody play guitar? No?
I play bass.
Okay. Daddy played bass. So
Slapping the best, man.
Hey, wait a minute. This guy in a band told me, he goes, "You want to play bass, son? There ain't no money below the fifth." And I was like, "What the hell are you talking about?" And then I found out you can be fancy all you want on the bass, but what gets you the gigs is doing the doom 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 doom. The fundamentals, right?
Yep.
There ain't no money in the. There's no money there. Nobody wants to hear that, and it doesn't work. Anyway, sorry.
If you take a guitar and you keep your just let the string go. You're not putting your hand on the neck, and you pluck a string. Let's say it's the E string. I don't play, but I know enough to be dangerous. You pluck the E string in the center, of the sound board. It will sing a note. If you pluck it again at where the bridge is, it will sing the same note. You're not changing the length of the string. It's the same frequency. It's the same note. It takes more pressure when you pluck it at the bridge because the impedance is higher. But the frequency is the same. That's just like your end-fed half wave. If you put your finger on the neck and you cut the string exactly in half, the frequency is twice as high. It's half the length, it's twice the frequency. Okay? So there comes a point where stuff, if you look at the bridge of a guitar, you'll see that each string on the bridge, they are not all the same length. One is a little shorter, one is a little longer. If you examine a bridge, okay, that is to get them to line up so that because the frets are all the same length, but the string behaves differently depending on the diameter of the string, its velocity factor. So that bridge is offset for each individual string to equalize them and take an average along the neck.
I never thought about the mass.
Yeah. Yep. It's
That's
tension
super
and
cool.
mass. It's both. Yep.
I never thought about the mass.
And by
That's
the
what.
way, there is a beautiful video of Joe Walsh tuning a guitar, and it is spectacular. I've never heard anything quite like it. I'll see if I can dig it out, Ziggy, and I'll send it to you in email. It is just
Joe Walls. I'll
Joe
share it
Walsh,
to the boys.
amp, and
Yeah.
and just fascinating because you can clearly hear after he's done with the tuning and moving the bridge and I don't know, I don't have the right terminology because I don't play, but he says I can see one of the strings is just about touching the neck. I need to bend the neck this way, put a little torsion the other direction, this, that, and the other, and all of a sudden the thing just it's polishing an apple. It comes to life, whereas before it was in tune, but it didn't sing as a chorus, and now each string supports the other. It's magic. Once you hear it, you almost can't unhear it.
Hollywood, do they have the dipole with the legs that go the capacitive legs? Is that what they're called? The dipped legs in the HF multiband, like in the ones that they give you with the software.
I do you mean like a capacitive hat, like you'd find on a vertical?
You sent me the file. Maybe I should just dig up the file that you sent me.
Take a look in the Hollywood folder.
Yeah.
Okay.
I don't remember what I sent you.
You sent me a doublet or a dipole, but it had the capacitive wings that drop down and then drop back up. And what that did is it like completely changed the harmonics for the multiband aspect.
Yeah.
So,
I don't remember what I sent.
So like adding a little
we'll do it another time.
Thing at the end that kind of like goes down and goes back up.
Instead of the dipole being straight,
yeah,
they were kind of zigs. There was a little droop before the end of the
like
wire
curtain.
on either side.
That's what I was saying. Like, what would happen to this if you kind of zigzagged it, type of thing?
Well, let's screw it up. Let's do it.
Is that what you're talking about, or are you talking about like curtains?
Here, let's take this a little. Let me edit. Or I wasn't edit. I'm drawing. Let me edit this. I've selected it. That's where I always screw this up. Let's move it. No shit.
Don't you need to like divide it or?
There we go. Okay. So let's bring that up. Let's bring you. You got to select first, guys. That's the trick. And then you draw a line. You draw another line. Right? Nope, I was in the wrong view again. I always screw that up. That's okay. I saved it.
I was in the right place. Must have been the wrong time.
Yeah. I saved it. Reopen. Fold it. Damn it. Okay. And let's redraw. But let's go to get off Z, Ziggy. Just because it starts with a Z doesn't mean it's okay.
Well, don't you want to be in this, Zed?
Do I?
I think you want to be in the Z, right? If you go up and down.
I want to be Y. YZ. No, you're right. Because I want to be this one. I want to be the far end. I want to be YZ. This one. Okay, so I think the thing is that's the fed side.
Just divide it in fourths and then or eighths and drop one node down.
Okay. That sounds pretty cool. All right, so we've divided it into fourths.
Yeah, and then pick
so
one of the part in the middle and just drag it down a little bit.
Drag it down.
Yeah.
See, I'm guessing because I don't know which way this is gonna view. Wrong direction. That's okay though. I mean, kind of
It's
does
close.
the same thing. Kind of does the same thing.
Okay. Run it. Send it.
No, let's drop it down in the same plane as the counterpoise. But yeah, screw it. Let's
Yeah.
run it. Yeah. Let's see what we've done here.
This is the cool part about the software.
That's right.
You can't
Send
break
it.
it. You can break your brain, but you can't break the software. Okay, so let's.
Didn't look like it really changed.
That
a whole
tells
lot.
me. That tells
Exactly,
me nothing.
Paul. Right. And this might be
tells me-
very useful if you have a really small backyard. You can bend that wire.
And it doesn't care.
It doesn't care. Yeah.
It doesn't
Not
care.
on not
but
on
it
the
might-
not on the main
not on the fundamental.
harmonic. Right.
Right.
Not on the
But-
fundamental, right. But it will
but if
as
we-
you go up. Yeah.
So then,
If
yeah, do that. Do that. Yeah.
we screwed up here, let's see what happened with the current.
And again,
What band
you'll
is
still
this?
you'll even if it's a lousy,
15.
you'll still
Okay.
make contacts on it.
Yeah,
Yeah.
15's a little rough because there's a high current point here and there's a high current point here.
Mhm.
And also too, guys, I wanna tell you that this blue is the blue and the red lines is the vertical and horizontal.
Correct.
Right.
They're
That-
both current, but one is vertical, the blue, and the red is a other way around. Excuse me. The blue is horizontal, and the red is vertical.
But how cool is this, right? We just happened to come to a null at this V on
Mhm.
on this frequency. This is totally by accident. So we've got 1, 2, 3, 4, 5, 6.
So
with some
Sean,
change.
if you built a Sturba curtain and you bent it in a parabola, that's probably pretty close to what you're talking about.
Interesting.
Got some smart stuff here. You just typed us.
Yep, I agree, Del. It is the tension on the strings, yes, because that we can change. But two strings at the same tension, the one that has more mass will resonate at a lower frequency. It's both. It's tension, and that's why the lower frequency strings are thicker.
Hollywood.
And that's
before
all
we
stringed
go,
instruments. Yeah.
What is your favorite?
My favorite
antenna off-
centerfold?
Your favorite. You already sent that one to me. What's
Oh.
your favorite antenna within the basic library within this software? The Mamanagal, and you go to antenna with here. What's your favorite one that you would love to show people or students?
I don't know off the top of my head.
Okay. I would imagine it would be either within HF simpler multiband, or maybe even.
I would say the
VHF.
multi-band. Well, you know what? We haven't looked at. Do a Yagi. Bring up a
Yagi?
Yagi, and let's just look at that. Yeah.
Where's Yagi gonna live?
Isn't that the bottom one? I can't read it.
No, it says Ziggy's antennas.
Oh,
and
that's
it's,
not
it-
Yagi.
and it's this V thing. I think I was.
No,
working
no,
on.
no.
I'm hating on the V's right now, so that's why that's a. And
So
I'll
go-
tell you
go
why.
back to the-
Hold on. No, this is great. This is great. Go ahead. I'm sorry. I'll go back.
They're there
unless
in
you
the.
want me to-
They're there in a folder. There are
Okay.
Yagi antennas in this software
I'm
that comes
hard hating on
preloaded.
V's. So let's maybe go to.
So I'm just suggesting that we look because we've spent, and I've got to go pretty. It's 1:00.
VHF
It is.
V's,
Yes, it is.
or
I'm going to need more toothpicks to keep the eyelids open. So
I
I
kinda
love
have
picking
the
my
same
teeth. I
problem.
love picking my teeth, homie. Loop dipole vertical.
no, go up one level. It's not under dipole.
It is not.
No.
It's not.
Read
under
them off.
types
Read
of
them off because I can't
Yeah.
see it. Print's too small.
Feeders, beams. It's
Yes.
a beam. It's
Yes.
a beam. All right.
Yes.
We got a bunch of beams here.
There's one there. There's a 20 meter or a 10 meter. Go to 10 meter Yagi. I know there's one there.
You just search.
I got a V Yagi, rhombic quad Yagi. I got a ZL20.
Sure. That's going to be a 20-meter Yagi. Great.
Hey, there's
Okay,
the
so
Yagi.
it's a
All right, let's
two-element.
run it.
Okay.
Okay. And
Just
it's
run it
folded.
at 20 and look at where the current is.
Is that folded?
Yes.
Okay.
I think.
It looks folded.
It looks like it.
So
I lost my mouse. Sorry.
But just run it and look at the current, because that's what's really telling.
That's what's whoa.
So that's because your current is zoomed in.
I know. Sorry. I like to exaggerate things.
Yep.
Sorry.
Yep.
All right, where's up?
Can you fold any wire antenna into a Yagi shape then?
That's a tough question.
What they're doing, Chris, is that you've got them confused a little bit. You can fold a dipole back upon itself, and then it goes from 75 ohms to 300 ohms.
Okay.
If you make two of them on a boom, that's what you're looking at.
Gotcha.
Okay.
Did you say from 75 to 25?
No, 75
No.
to
300.
300.
That's what you said.
Yep.
And then you collinear those 250s or those two 300s to get back to 50? No, that doesn't work that way.
No.
Yeah.
So Chris, what this is it's just a dipole. Is the one with the red dot? That's the one that's being fed the RF.
Yep, that's
but this is the important part. Look at this.
Oh,
Right.
it crosses.
Right. They're actually
Yeah.
both. This is not your standard Yagi. They're both being fed RF. Whereas a standard Yagi, the reflector does just that. It takes the signal that it sees, it reflects it off of it, and it spits it back forward again to reinforce with the first wire.
So
this one, they're both hot. They're both hot.
So what's the
Hollywood,
3D
this is a
view?
great question.
Okay, so Sean, it is a reflector because it's out of phase, but it's out of phase because of the crossover halfway down the boom. So what we're calling the reflector is 180 degrees out of phase with the driven. They're both driven, but the front element, it's 180 degrees out because of that twist. It's flipped. Phase is flipped halfway down the boom. That's what Ziggy zoomed in on.
Yeah, and they're 90 degrees opposite the direction I thought it would go.
Yep. So there's a electrical, mechanical change. That's the 180, and there's a phase delay because of the physical spacing between them. So it's both.
Is there anything you can say, Hollywood, about this current?
Right
here?
That's the transmission line that's on the boom, and it doesn't mean that it's radiating. It just means that there is current there. It's a low impedance, high current point.
Right. Because this wire is not invisible.
Right.
Between element 1 and element.
It's there, but it's not radiating. I mean, it is, but it's such a minimal amount. It's
So I assume on geometry, this is tuned for 20 meters. Oh, wow.
Mm-hmm.
That thing is a hammer, dude.
Mm-hmm. Mm-hmm.
With only
Show
2
that.
elements. Get out of here. That thing is a hammer. Whoa!
Wow.
Yeah, dude.
Mm-hmm.
Damn.
Because it's not relying on the reflector. They're both
only
fed.
2 elements? Dude, it doesn't hear anything on the back. Look at that.
That's right. And I hear
Complete-
that, I hear this a lot. I'm talking to you. Some guy in Europe I'm talking to. And he says, I can hear you on the backside of my beam. What does that tell you about his beam? There's something wrong with his beam if he can hear you on the backside.
Bro.
Yeah.
Dude, this thing is a hammer.
Yeah.
It's only got 2 elements. I'm changed. I'm reformed.
Wow.
I used to think like the 2 and the 3 element Yagis were had some trash like front to back. This thing has 2. Look at the null
Wow.
right here. This tells you everything you got to know right here.
Yeah.
This is the black hole of the antenna.
You won't get
You
nothing.
ain't hearing shit back here. Ain't happening.
Nope.
Wow. Two
That's
elements
crazy.
folded.
This is
Now
why I
let's
love
put
this
some-
software.
Let's put some ground on it, right?
Yep.
Let's make it real. We're
Yep.
in free space. Let's go to real, and let's say that I don't
So
know,
could
30
you
feet up.
fold? Could you fold a dipole then into that kind of a shape with some structure, sticks or something, to like make it do that? Holy crap!
Right, so here we are. What did I put it at? 10 meters, 30 feet up.
I think it's like
Yeah.
a diamond ring.
Mm-hmm.
Damn, dude, that
Blast
thing is
in
a
the air.
hammer.
So it's all forward, and you see that
Wow.
its takeoff angle is a little bit elevated
Here, let's
because
look at
it's reflecting off of the ground as it takes off. So what hits the ground?
10 dB with just two elements.
Yep.
I don't
Yep.
believe this, Hollywood. Something's
Well, it's
wrong.
okay. Understand too.
What?
It's not 10 dB D. It's 10 dB I.
dBi. Right. DBD
Okay.
and dBi are not the same.
Dang.
So
Right.
that-
It even
it can
clarifies that for
be
you
misleading
right
if you
here.
don't catch that. Right.
It even clarifies
That's
that
why,
for you right
because
here.
like the Antron 99, it's 9.9 dB of gain. No, it isn't. It's 9.9 compared to an isotropic radiator. It's dBi. It's really like 3.5 in the best situations, like 3 dB over a dipole. It's a J-pole.
Because I want to see if I can make this now.
Yeah.
You can
Right.
buy it, I'm sure. I think it's a
And there are
somebody's got
and there are a
does
ton of other samples and examples in this software that when you get the software, it comes preloaded with all of this stuff.
Hmm.
So
and this is the base package, and there's many like mega
Yeah.
packages
Yeah.
that you can get.
right.
Yeah. That's great. Hollywood, thank you so much.
You're welcome.
For
You're
showing
welcome.
up.
This is why, in the wintertime and I got nothing to do, people don't see me for a month. He never leaves the house. Where did he go?
Tio was asking for you. He was wondering why you weren't on stream lately, and I'm like, well,
Been playing with antennas.
been playing with antennas.
Dude, that's awesome.
Yeah.
Wow.
All right, gentlemen, gotta go.
Yes, thank you.
It's been real.
And
We'll
like
do it
a lot
again.
of us are really smart. I'm really smart.
Paul's got this soundboard kicking now. He's pro stream stat.
Yeah.
Awesome.
Dell says thank you as well.
You're welcome, Del. Anytime. All right.
Yep.
This would be a nice mesh.
Until next time, gentlemen.
Yes. Until next
Onward
time.
and upward. Have fun. 7-3.
7:30.
Seven. 5.
Adios. Sayonara. 77.